Okay, so good morning, everyone. I hope all the participants have joined now for this session. Good morning, Charu ma'am.
Good morning.
Okay, so today we are having with us Dr. Charu. She is an architect and a town planner by a profession, presently working as a professor at Amity School of Architecture and Planning, Noida. She has 23 years of working experience, out of which more than 19 years have been dedicated in academics as a successful academician. She has completed her PhD in the domain of architecture and planning, linking the impact of built environment on crimes related to women in urban areas. She has published number of research papers in reputed national and international journals and guiding number of PhD scholars carrying out their research in different areas. Having a specialization in housing at postgraduate level, she has guided number of students for thesis and dissertation projects both at UG and PG level in architecture and city planning fields. She has a lifetime registration number with Council of Architecture and also associate member with Institute of Town Planners of India and Institute of Architects. So in this today's session, we would like to welcome Charu ma'am, and now we'll be continuing with our sessions. I request our first participant to kindly present their presentation. Arpita, are you there?
Yes, ma'am.
Okay. So one thing more, you have only 10 minutes to give your presentation, 8 minutes for presentation and 2 minutes for question and answering sessions.
Yes, ma'am. Yes.
You may continue. Thank you.
Yes.
Shivangi, you unshared your screen. I think
Yes.
You have shared the screen.
Can I share now, ma'am?
Yeah, please
Yeah.
go ahead.
Ma'am, good morning all. Is it visible, ma'am? Screen?
Yes, screen is visible, your presentation is not.
Yeah. We'll start now. Yes, ma'am. Good morning, one and all. Myself, Arpita. I'm presenting here as a scholar, PhD scholar from.
Ma'am, your PPT not visible.
Your screen PPT is not visible, sir.
No, only folder we can see.
Okay.
Many folders in this.
Okay, sir. Okay. Ma'am, now is it visible, ma'am?
No, not yet.
I shared the screen here. It is showing you are sharing your screen.
Ma'am,
Screen
reshare
visible.
your screen, ma'am.
Yeah. Sir, what about now?
Yeah, it's okay. Just keep it in slideshow mode.
Slides move.
Slideshow, yeah.
Yes, I keep it in slideshow only, ma'am.
No, it's we can see it's a normal mode only. Left side and we can see your slides, and right side menu.
Same thing. No? What about now, ma'am?
You press F5.
F5. Yes, ma'am.
Can you put it on presentation mode?
Yes, ma'am. It's in presentation mode
No,
only.
it is not. Can you click the third button from your left? Down. 69% के साथ वाला. Where 69% is written on your screen.
Okay.
The next button to that. Click that.
Next button.
On the bottom, can you see 69% at the bottom?
No, ma'am.
I can see on your screen.
Yes. Now, ma'am.
Now you have to click the button which is beside 100%. The next button to 100%.
Next button to 100%. Yes.
On the left. On the
Yes,
left.
ma'am.
On the left.
I think, ma'am, it's Office 2007, and Office 2007 is not supporting Zoom slideshow mode.
Oh.
What about now, ma'am? It's more than 100 only.
I can see only the part of your screen, not the whole screen.
Ma'am, keep it 69% only.
Okay, I'll make it less than that only. Yes, sir. What about now?
Ma'am, click slideshow at the top.
Yes.
Slideshow mode is not supporting Zoom because this is Office 2007.
Okay.
Adjacent to animation.
Older version is not supporting Zoom.
Okay.
It is not supporting.
Yes, from beginning.
Sir, this is okay, sir. Can I start now?
Press from beginning.
Yes, sir. Support. Sir, can I share the PDF PPT? Is it okay for that? If it is not supported.
Okay, you can continue in this mode. Actually, we have so many students for the participation as well as the delegates. So you continue.
Continue. Yes, sir. Yes, ma'am. Good morning, one and all. Myself, Arpita. I'm a PhD scholar from Reva University. The title of this review paper is a review on carbon dioxide uptake by recycled coarse aggregate and cement-based materials. I and my guide, Dr. Kannam Praveen sir, will be an authors for this paper. This is the content of my project as I am explaining one by one. See, in this project, in this review paper, I'm going to explain the carbon emission and its utilization when it is coming with respect to the recycled coarse aggregate conditioning and also with respect to the carbon curing. This is the major agenda. And here will include when the carbon dioxide curing is done for the given RCA and also the cubes, its physical performance regarding absorption and crushing parameter. And also it is explained in terms of sustainability, recycle and reused materials which can be proposed for further testing in the laboratory, and the technology scope for the environmental benefits. This is the abstract. For selecting this topic, why we need to select the carbon Q?
Sorry, Arpita. Slides are not moving. We are not able to read.
For me, it's moving, ma'am. Even I'm giving the slide share also.
Okay, continue.
I already sent the slide to the respective person, ma'am. Can I?
Dr. Priyanka, can you help me in this?
Okay, Dr. Arpita, what you can do, you can arrange other laptop for your presentation. Meanwhile, we will carry out with the presentation of other participants.
Yes, ma'am.
Shivangi, who is the other one? Next one.
Yes, ma'am, I'll be presenting.
Yeah, go ahead.
Is my PPT visible now?
Yeah, it's there.
Okay, so good morning, everyone. Myself Shivangi from Amity School of Engineering and Technology. And the title of my presentation is Optimization of Mix Design for Concrete with and Without Polypropylene Fiber. And the author of in my paper is Dr. Priyanka Singh and Dr. Basar S. Mohammed. I think it's stuck. Just a minute. Is my slide moving?
No, we can see the title slide only.
Yeah.
No, it's there.
So to start with, we'll be covering introduction, problem formulation, methodology, result and discussion, conclusion and references. To start with the introduction, so basically in today's era, construction is becoming demandable on a remarkable high pace, leading to great utilization of underdone materials in concrete mix. While discussing about the foremost materials used in construction, fine aggregate and coarse aggregate is the material that is used adequately. Showering light on use of polypropylene fibers as an admixture in a bare concrete mixture, many types of research are carried out in concrete using fibers, proportion, and different grades. The experimental result demonstrating that the use of this polypropylene fiber in varying percentage, that is 0.5%, 1%, 1.5, and 2% in M30 grade concrete mix leads to tremendous improvement in various properties of concrete. Compressive strength of concrete with and without polypropylene fiber at varying percentage has been exhibited for 7 days and 20 days of curing. The current work designates the appropriate consumption of polypropylene fibers as a beneficial construction material. Coming to the problem formulation, so basically to carry out the experiment, to reach to the conclusion, setup has been done in the laboratory and following arrangements were made. Further, this table gives the information regarding mix design proportioning for M30 grade concrete with and without fibers, which has been considered. This table 1 demonstrates the mix proportion which has been used for M30 grade concrete with and without polypropylene. So for the mix proportion, we have used cement, fine aggregate, coarse aggregate of 10 and 20 mm respectively, and water. After that, we have added polypropylene fiber in 0.5%, 1%, and 1.5 and 2 percentages. After batching, various tests has been performed to know specific gravity as well as workability of the concrete mix with and without polypropylene fiber. So we have used picnometer method. In this method, we have used to know the specific gravity of fine aggregate, which has been further used while doing mix designing of M30 grade concrete. Figure 1 demonstrates the apparatus picnometer, and the specific gravity which we have achieved is 2.564. The next method we have used is Bansi method, and then this method we have referred to know the specific gravity of coarse aggregate. And further this while making a mixed design of M30 grade. So basically figure 2 demonstrates the apparatus, Bansi apparatus, and specific gravity is obtained as 2.649. Third, we have done the slump test in this experimental method. And this method has been used in the laboratory to know the workability of the mix that has been prepared. Coming to the methodology, so we started with the introduction portion. We have carried out literature review, and we have done optimization of mixed design of fiber reinforced concrete, and done the study of the optimization of the fiber material considering the compressive strength. Finally, we have implemented the polypropylene fiber in the chop form, and we have carried out the study for the new mix with compression investigation. And then we have done the quantification of outcomes and conclusion. And finally, publication and preparation of reports have been done. Coming to the results and discussions. So first, let us consider workability. So after preparing M30 grade concrete mix in mixer, slump test was performed on concrete with and without fibers at different percentages, and slump value has been derived to know the workability of type of concrete as shown in table 2. Even length of fiber also affect the workability and results in the reduction in the slump value. As we can see, when we have used bare concrete, that is without adding any proportion of polypropylene fiber, we receive the slump value of 65 mm. And further, when we have added fibers at different percentages, we have seen our slump value started decreasing from 60 mm to 40 mm at different percentages. Talking about the compressive strength, so after 7 days and 28 days of curing, it has been taken out and kept in a universal testing machine, UTM, to get the desired compressive strength of the design concrete with and without polypropylene fiber. And the specimen have been tested under compression testing machine of 1000 kilonewton capacity. Henceforth, outcome of compressive strength at different percentages of fiber, that is 0.5, 1.5 and 2% has been demonstrated in the graph. We can see at different percentages the compressive strength that we have received after 7 days of curing and 28 days of curing. Coming to the conclusion, so M30 grade concrete mixed with 0% fiber content, that is bare concrete, when tested on UTM machine of 1000 ton after 7 days seems to attain compressive strength of 22.4 Newton per mm square, whereas concrete with different percentages fiber attains very low compressive strength of 12.7, 11.77, 11.29, as well as 9.18 Newton per mm square at 7 days of curing. Whereas after 28 days of curing, compressive strength of 29, 20, 21, 14, and 15 Newton per mm square were achieved. Secondly, after 7 days of curing, compressive strength of concrete at varying percentage of polypropylene fiber decreases when compared to bare concrete and was found to be decreased by 43, 47, 49, and 55 percentages. It was also seen that compressive strength gain at 7 days of curing was very low for M30 grade concrete mix with varying percentage of polypropylene fiber. But when tested after 28 days of curing, drastic increase were noticed in compressive strength when compared to 7 days of curing. For varying percentages of fiber content in M30 concrete mix, following percentage of increase were noticed, like 4.5% after 7 days. After 28 days, it was seen that 37.03% increase were there when compared to 7 days. Similarly, 44 was for 1% and 28 for 1.5%, and for 2% it was seen to be 34.5% increase. While adding varying amount of polypropylene fiber in M30 grade concrete mix, it was seen that maximum compressive strength was achieved at 1%. That is when we have added 1% polypropylene in the M30 grade concrete mix. And minimum compressive strength was achieved when we have added 1.5% of polypropylene fiber. Despite of adding fibers in concrete at varying percentages, it can be concluded from the experiment which was carried out that the concrete mixed with 0% polypropylene fiber has more compressive strength after 28 days of curing. From now on, when polypropylene fiber is used as an additive, it can affect the range of compressive strength by lowering the compressive strength in comparison to the identical plain concrete mix, and decrease in the compressive strength was thought to be caused by the incursion of the fiber within the cement matrix of the concrete, which due to their lower bond strength forms a break in CHS bond between cement and surrounding aggregates. Hence, we can conclude that M30 grade concrete with polypropylene fiber have low compressive strength, but it was found to be more durable and more economical. So it can be used as a hybrid fiber in combination with some other fiber in order to give more strength to the concrete structures. These are some of the references which we have referred. Thank you. Anyone having any questions so that I can clarify?
Thank you, Shivangi. I think you are doing a research on a very, very important topic. Nowadays, concrete being the major and one of the most important building material is used in the building construction industry.
Yes, ma'am.
Can we go to the slide of which you showed the conclusions?
Yes, ma'am.
The slide you showed for this one. So let's see the point number 3. In point number 3, you have mentioned that when M30 grade concrete mix was cured for 7 days,
Yes, ma'am.
The compressive strength was less, and when it was cured for 28 days, the compressive strength was increased drastically, right?
Yes, ma'am.
So my question to you is like, as you know that now is in the current scenario, in the current era, the construction is very fast. Everybody wants to build buildings in few days.
Yes, ma'am.
And you must have seen few examples in Japan and other developed countries.
Yes,
Where
ma'am.
buildings are being, especially in China also, where buildings are being built in a week. In 7 days, 30-story buildings are being built.
Yes, ma'am.
In that scenario, how this kind of mix will help when we need to achieve the maximum compressive strength. So, as a scholar, what is your observation on this?
Ma'am, actually, I'm studying at different materials. So for the polypropylene, many places they are using polypropylene fibers. But when I carried out the test, I noticed that polypropylene fiber compression strength is not that much good. Although it is giving more durability and it is more economical. So further, I'm carrying out the test and I'm trying to make a combination, or you can say a hybrid material. Like I'm trying to mix polypropylene with some other material so that we can get more compressive strength, more durability, and it can cure in a very less time. That's why my final conclusion was like, for me, I don't see this as very beneficial material, though it is being referred in the industries nowadays. So I'll be further mixing it with some other fibers, so that it can become more economical, like I can use with a glass fiber or carbon fiber or something like that.
So as a scholar, you are actually searching for the new material, right?
Yeah, like some good hybrid combinations which we can get.
I think it's a very relevant research in the present times, and I must congratulate you to take this topic, and I wish you all the best for your thesis and your PhD. Thank you.
Thank you so much.
Dr. Priyanka, can we go for the next?
Yeah. Akshima, are you there? Akshima?
Yes, ma'am. Good morning, ma'am.
Good morning. Are you ready with your presentation?
Yeah, ma'am. I'm ready.
Okay, so you can start sharing your screen.
Okay, ma'am. Just a minute. Is it visible?
Yes, it is.
Yeah.
Put it on presentation mode.
Sorry?
Slideshow mode. Please put it on slideshow mode.
Yeah. Wait a minute. Okay.
Yes.
Yeah. Good morning, everyone. My name
Now
is.
you have to keep on your webcam.
Yeah,
You're not visible to us.
yeah, I'm just facing a little issue with the camera, so just a minute. Is it visible?
Now you're visible. Please proceed.
So, ma'am, my laptop is facing some issues with camera, so I think it's. Is it visible now? Okay.
No, you're not visible now.
Yeah.
Now you proceed.
So the angle will be not so good, but yeah.
Okay. No issue.
Good
You can
morning.
proceed.
Yeah, okay. Thank you so much. Good morning, everyone. So title of my paper is Addition of Marble Dust and Polypropylene Fiber in the Concrete Mix. So as I have heard that the previous participant have given the PPT on addition of polypropylene in concrete mix. So my topic is about adding some percent of marble dust and also some percent of polypropylene fiber in the concrete mix, so that we can check all type of strength and compare it with two types of concrete mix. So one is M25 and other is M30. So the fellow authors are Mahendra Kumar Singer and Ravikant Parekh. Ma'am, the screen is not working. So the content which I have to speak about are introduction, literature review, problem formulation, methodology, research discussion, conclusion, and references. So first, we are starting introduction. As we know that concrete is a mixture of aggregates such as coarse aggregate, fine aggregate, cement, sand, and other additive and admixtures which may be present as per the requirements or as per the quality of construction which we are about to happen or about to construct. Aggregate are the most important component because cement are employed to mix with the concrete. Cement has been a competitive building material due to its properties, relative economy, and high versatility, which meets a wide range of need. The demand of concrete is in today's infrastructure expansion is gradually increasing day by day. As we know that concrete without reinforcing is brittle in nature, which have very poor tensile strength and limited strain capacity. So from ancient time, means from a very previous time, we are using fibers to increase our flexural and tensile strength of the concrete, so that the durability of concrete will be increased. Since the time, many types of fibers are used, such as carbon, steel, glass, and as well as polypropylene fiber have been employed in the concrete. The addition of fiber to concrete affects its brittleness and ductility. Polypropylene fiber improves several qualities of concrete mixes, including tensile strength, flexural strength, splitting strength, toughness, strength of the impact, and also define the failure modes. Polypropylene fiber is used because it binds the concrete mix together, slowing the settlement of coarse particles and reducing bleeding, which indirectly slows the rate of resulting in the less shrinkage. This research investigates the effect of polypropylene fiber on concrete mix with replacement of cement is done with the help of marble dust. And also we have concluded the comparison between two types of concrete mixes, which is M25 and M30, to analyze a cost-effective parameter. So the percentage of replacement of cement has been taken 10% of marble dust, and in case of polypropylene, we have taken 0%, means in the percentage of it. Problem formulation. So why we have used polypropylene? So what are the objectives to use polypropylene and marble dust in the concrete mix? First one is to reduce the cracks which are developed because of the plastic shrinkage. Second one is to increase the different strength of concrete using polypropylene fiber and with the marble dust. Third one is to reduce the damage occurred by liquefying, sub-freezing and fire in the concrete mix. Next, to decrease the failure of impact load and to provide proper resistance in concrete against the failures. To analyze the workability of fresh concrete and what are the materials we have taken. As I have used these tests in Ahmedabad. So the materials are also from Ahmedabad only. So we have used Ultratex cement, which is of OPC grade 43, which has a specific gravity of 3.1645 and fineness of 93% and was obtained from Ultratex cement plant only, which is in Bharuch. Aggregates are granular materials made up of crushed rocks. Aggregates alone cover 60% to 75% of total concrete volume. Coarsely crushed are used. 20 mm coarse aggregate are used with a specific gravity of 2.76 and water absorption of 0.5%. Sand used is natural river and with a specific gravity of 2.66 and water absorption of 0.5%. Sand used is of a natural river sand with a specific gravity of 2.66 and water absorption is 1%, which are obtained from Jai Boga Construction Ahmedabad, which transport the sand and other materials to the sites nearby us. Marble polishing waste was collected from the industries, which is basically from Kishangarh marble industry, which is in Kishangarh, Rajasthan, but it is also transported by Jai Boga Construction, so I have taken from that only. So Ahmedabad has a specific gravity of 2.77, fineness of 24.4%, and water absorption of 1%, and the sand we have used has the pH of 8.89. Polypropylene fiber used in this study is Dolphin Floats Private Limited, India. Product name is Nokar. Okay, so methodology. What methods are we have used to check all the strength and compare it with the two basic concretes? So first one is water absorption test to check what amount of water we are using or we have in the mix. Second one is pH of marble dust, because we have taken the wastage of marble, which is a powder. We have replaced it with a percentage of 10. Slump for concrete mix with both of the mixes, M25 and M30. Slump with, we have added 10% of MDP and polypropylene, and again check slump so that we can check the workability. Next, comparatively compressive strength of M25 and M35, splitting strength of M25 and 30, and flexural strength of M25 and 30. So what are the results and discussion we have kept? First one, we have concluded that when we are talking about compressive strength, split tensile strength, flexural strength, all type of strength which we have gained from these comparison. When we are talking about M25 and M30, so we have used in 0 different percentage of polypropylene fiber, which is in 0, 0.5, 1, 1.52. Means we have added it in 0.5% in addition. I'm so sorry. We have taken 60 polypropylene reinforced concrete prototypes. Means we have made 60 cubes to check these. And we have taken and we have casted them in 7, 14 and 21 days. Slump tests on fresh concrete were taken during the concreting casting to verify workability in the percentage of addition of polypropylene fiber in same percentage, 0 to 2%, with the addition of 0.5, additional 0.5% extra. Next is, in this study, the water cement ratio is 0.45 and total of 120 PERC, which is polypropylene fiber reinforced concrete, was casted. The percentage of PPF, which is polypropylene fiber, used in current study is 0 to 2% with 10% of marble dust, which is the main criteria of this research. So increase in compressive strength is checked, which is found 29.82 for M25 and for M30 it is 12.61. Next, the increase of tensile strength when we have compared both the mixes, then it came to be M25 plus 10% of marble dust is 45.53 and 23.72 for M30. Increase in flexural strength when we have compared both of the mixes, then it came to be 30.76 for M25 and for M30 this is 25.18. These are some references which we have taken or from which we have just checked some other things. These are the references. Thank you so much.
Thank you, Akshima. Can we go to the slide of on conclusion?
Yeah, ma'am. Sure. Yes, ma'am.
Your fourth point, the increased flexural strength of M25 and M30 with polypropylene and 10% marble dust was
Yes.
found to be 30.76 and 25.
Yes, ma'am.
Let's say that what is the amount of polypropylene you added to this?
Actually, we have added to 0.0% to the point of 2%. We are just added 0.05 at the every stages so that we can check about that thing.
So what is your observation that 0% or 0.5 or 1.5 to 2, what percentage of polypropylene will work or works the best?
Ma'am, as per my research and my thoughts, the 0.2 and 0.2% is 0.5% is good for the construction.
0.5%, that means 0.5%, right?
Yes, ma'am.
And then you add stone dust to it extra and then you get the...
Yes, ma'am. Actually, polypropylene fiber has given a little amount of strength and with some of negative things. So to recover that things, we have added 10% of marble dust, because as we know that the wastage of marbles are also having some adhesive property, which can increase some of its strength.
So you want to use marble dust as a additive material?
Yes, ma'am.
Which increase the flexibility and the additive property of the...
Yes, ma'am.
concrete.
And also durability. It gives durability to the concrete mix.
So what kind of buildings will you recommend for using this kind of concrete? Like, will it be bridges or will it be large span structures like airports and all?
Ma'am, high-rise building can be used or can be constructed from these type of replacement.
High rise, that means
such thing.
About 12 floors, you're saying?
Yes, ma'am, about 12 floors.
Okay, so will it be cost effective and time?
Yes,
time?
ma'am. It is cost effective.
Okay, cost effective. Because the scholar who is presented the presentation before you is also researching on the same, almost the same topic.
Yes, ma'am, I have seen that.
She is looking for another material which can be added with polypropylene to get the best result.
Actually, ma'am, I have started this research with bacterial concrete.
Okay.
After that, I have researched that there's no such increase in strength found in bacterial. So I have just turned my topic to polypropylene. And after working in polypropylene, I just thought that why can't we add some other things to it? So I have searched some things and I have just researched about marble dust. So I have added that, and in future, I'm about to do PhD. So I'm about to start a PhD.
Okay.
So I'm just thinking to just add some more additive. Maybe we got some beautiful results with it.
Okay. All the best. Thank you.
Yeah, thank you so much, ma'am. Thank you.
Okay, thank you, Akshma. Next participant, Hemant, are you present?
Yes, ma'am.
Hemant. Okay. You can start your presentation.
Is I am audible?
Yeah, you are audible.
Start. Is my screen is visible?
Yes, yes. Please keep it in slide mode.
Okay. Good morning, everyone. The title of my paper is Partially Replacing Cement with Ground Granulated Blast Furnace Slag GGBS and Fly Ash Changes the Mechanical Property of a Concrete. Continue. Introduction. Concrete cement is widely used building substance on earth. It works as a binder material. It set and become adhesive due to hydration. Ordinary cement concrete has a very weak, limited ductility, tensile strength, and little resistance to cracking. Additionally, its quantities are going to improve with addition of new material and the use of waste material from a variety of sources. So by using waste material in concrete, we can make it cheaper while also reducing the amount of waste material that serve no use and get thrown away. GGBS is one of the greenest construction material. Manufacture of GGBS utilize all of the slag and produce no significant waste stream. GGBS in concrete will be eco-friendly and economical. GGBS is a waste industrial byproduct of iron industry. Thermal power plant that use coal as fuel produce fly ash as a byproduct. Fly ash comes from one of the biggest source of air pollution and carbon dioxide emission on earth, and yet it is considered to be green material. The main reason that fly ash is considered to be eco-friendly when used in construction is because it's recycled material. If power company are going to burn coal and produce fly ash anyway, it makes sense to put it to good use, especially if it can save money and energy in construction sector. It is possible that fly ash can harm agricultural land, pollute surface and groundwater soil, the air, and cause other diseases if it is not properly disposed of or released into the environment. By incorporating fly ash into cement concrete, it is feasible to bring the total amount of heat that is produced during the process of mass concreting down to a more manageable levels. Literature review. Sample material tested. GBS Portland cement test performance of concrete incorporating GGBS in aggressive waste water environment. Finding. He investigate that the use of high quantities of GGBS greatly enhance resistance of Portland cement binder in respect of sulfate attack. Reference M.O. Colin. Sample material tested fly ash GGBS durability study on concrete with fly ash and GGBS. Findings. Strength of fly ash cement concrete when replaced with 20% is increased, and the strength of fly ash concrete when replaced with 40% cement is decreased. We recommended that the use of fly ash between 20 to 40% replacement with cement for better result. Reference AHL Swaroop International Journal of Engineering Research and Application. Sample material tested geopolymer concrete fly ash. Test performed strength, economic and sustainability characteristics of coal ash GGBS based geopolymer concrete. Finding. Curing at elevated and ambient temperature will form fly ash GGBS based concrete of comparable strength. Bottom ash GGBS based geopolymer concrete gives very low strength, probably due to large particle. Reference Mr. Vinit Jose, Matthew, International Journal of Computational Engineering Research. Sample material tested cement fly ash. Test performed effect of fly ash on durability properties of high strength concrete. Findings. The fly ash concrete yielded better resistance to chloride and penetration both at 28 and 180 days. Thus, it is possible to design high strength concrete of reduced permeability by including up to 40% class F fly ash in the total binder. Reference P. Nath P. Sarkar, the 12th East Asia Pacific Conference on Structural Engineering and Construction. Problem formulation. First step, understanding the properties of concrete. Second, evaluate what are the material which we can use to increase the mechanical property of a concrete. Finding the waste and economical material that should enhance the property of concrete. Use this material in concrete mixture and evaluate is there any increase in compressive and tensile strength. If increase in strength is obtained, then we are going in right direction. Methodology. 24 cubes of size 150 mm and 24 cylinder of 300 mm into 150 mm were casted to be tested on 7th and 28th day of water curing by adding GGBS and fly ash with M40 aspect ratio with proportion by weight. After the testing of each cube and cylinder, we got the value of compressive and split tensile strength for different batches. The compressive and tensile strength of cement concrete are affected by addition of GGBS and fly ash as replacement of cement according to finding of the current study. The concrete mixture made with GGBS and fly ash places 0%, 10%, 20%, 30%, 40%, and 50% of cement by weight. The following are the conclusions regarding the origin of result of a current experiment. These are some side pics, the casting of cube and cylinder. The design mix for M40 should be produced with compressive strength and concrete in mind, along with suitable amount of workability to ensure that new concrete can be mixed, put, and compacted correctly. The criteria for the water were taken from the document IS 1026 2009, and they were included in the calculation for the mix proportion. In the current research mix design of M40 design value at the age of 28 days, grade concrete is deemed according to BIS. The table showing the different proportion of cement, GGBS, fly ash, fine aggregate, coarse aggregate, and water. Results and discussion. Case study on the cement replacement with GBS. The concrete mixture were prepared with constant quantities of fine aggregate, coarse aggregate, and water. 5 types of mixture were prepared. GBS was introduced in concrete on replacement with cement by weight. Here we prepare a 5 mixture by varying the percentage of cement and GBS, G10, G20, G30, G40, and G50, and we get this strength. These are the table charts which are showing the result. At G20 percentage, G20, we get the highest compressive strength and tensile strength on 7 and 28 days. Now, further case study on cement replacement with fly ash. The concrete mixture were prepared with constant quantities of fine aggregate, coarse aggregate, and water. 5 types of mix were prepared. Fly ash was introduced in concrete on replacement with cement by weight. So here we prepare 5 another mixture with fly ash, F10, F20, F30, F40, and 50. And we get this compressive and tensile strength for 7 and 28 days. These are the charts which showing the result. In this, we see that by adding fly ash, we do not get high tensile and compressive strength. Our strength goes decreasing as we increase the percentage of fly ash. But it will increase the workability of concrete. Case study on cement replacement with GGBS and fly ash. The concrete mixture were prepared with constant quantity of fine and coarse aggregate and water. 4 types of mixture were prepared. GGBS and fly ash are introduced in concrete on replacement with cement and cement by weight. So here we prepare another 4 mixture by varying the percentage of GGBS and fly ash by making a constant percentage of cement. G10 plus FA40, G20 plus FA30, G30 plus FA20, and G40 plus FA10. So we get these results. These are the charts. So our conclusion is the addition of 10% of GGBS in concrete is found to increase the compressive strength of concrete by 3.36 megapascal after 7 days of curing. The compressive strength after 28 days of curing is also increased by 5.1 megapascal. Similarly, on addition of 20% of GGBS, the value of tensile strength of concrete increased by 0.11 megapascal after 7 days of curing, and the tensile strength after 28 days of curing was also increased by 0.2 megapascal. With the varying percentage replacement of GGBS 10%, 20%, 30, 40, and 50%, the compressive strength increase up to 20% by 3.36 megapascal, and then it start decreasing as the percentage of GGBS increasing. The addition of fly ash in concrete is found that both compressive as well as split tensile strength decreases, and further as the amount of fly ash increases in concrete, both compressive as well as split tensile strength decreasing. When both GGBS and fly ash used as a replacement of cement up to 50%, we get a varying result. As we increase the percentage of GGBS, we have to decrease the percentage of fly ash to make the cement content up to at least 50%. When GGBS is 20% and fly ash is 30%, then we get the maximum strength up to 28.34 megapascal for 7 days and 43.1 megapascal for 28 days. Similarly, we get the highest value of split tensile strength of 1.6 megapascal for 7 days and 3.1 megapascal for 28 days at 20% of GGBS and 30% of fly ash as a replacement with cement. These are some references. Thank you.
So what is your final conclusion, right? Should we add GGBS and withdraw fly ash, or the combination of both? Like your last conclusion states that if we add 20% of 30% of GGBS and 20% of fly ash, it gives the maximum strength, compressive strength, right? Can we go
Yes,
back to that slide, conclusion slide, the last slide?
Yes, ma'am. The question, when we
Just go the last conclusion, when both GGBS and fly ash are replaced,
yes, ma'am.
right? Then
Yes,
20% of GGBS and 30% of fly ash
yes, ma'am.
to be
We
added.
get the yes, ma'am. We get
So we
this
get
results.
the maximum. So what is your recommendation, that we should add GGBS?
Ma'am, when we have to gain strength early, then we should recommend that we should use GGBS
So how
because
much
it
cost
gives.
effective is it, like?
It is a ma'am waste product of iron industry.
So
It's not
it is also
much costly.
it is also a way to manage the waste and the output,
Yes, we
waste
can use.
output we can use. Okay. So what kind of buildings will you recommend with this kind of concrete?
Ma'am, we can construct a high-rise building or bridges by using GGBS as we get early strength in and get more strength, and we use fly ash in dams where mass concreting is done
Mm, mm.
because their heat produce is very large, which may cause cracking. So
And what about the flexibility part of the concrete? Will it affect the flexibility part?
yes, ma'am, fly ash.
Can we get any shape we want out of concrete, or it will affect that?
No, we can get any shape when we use fly ash, as it increase the workability also.
As
But
you know
strength.
that nowadays roads are being constructed out of concrete, which is very a required option because of the high traffic. So what about the roads? Can we construct roads with this kind of concrete?
Yes, ma'am, we can use GGBS also and rapid hardening cement, super rapid hardening cement, in which we use calcium chloride as accelerator, which help in early strength gaining of concrete.
I think you are doing a very relevant research, and I must congratulate you. And are you a PhD scholar, or this is just out of interest?
I'm tech student from Chandigarh University.
Okay, all the best to you. I think you can keep it up your research, and you will get best results. Also.
Thank you.
Thank you.
Ma'am, next, can I do, ma'am? Arpita, paper ID 88.
Yes, please.
Yes,
go
ma'am.
ahead.
I'll share the screen now. Good morning, all. Is it visible, ma'am?
No, it is not as yet.
Yeah, I arranged other laptop, ma'am. It's Windows 10.
No, I'm not able to see it.
Yeah, I give a slideshow. It's paused, ma'am.
Ma'am, we can't see your screen, ma'am. It's
wait,
only blank.
Here it is. So your screen sharing is paused. Hmm? Okay,
Arpita, you leave. We will share for you.
yes, ma'am. But it's showing your screen sharing is paused here.
Yes, now we can see, and please make it slideshow mode. Yes.
Yes. Sir, can I start, sir? But I can't.
We will control your PPT. You can start.
Yes. Initially, sorry for inconvenience, ma'am. My topic is, it's a review paper. I did it on carbon dioxide uptake, recycled coarse aggregate, and cement-based material. These are all the contents. Next. Next page. Yes. Abstract, the main abstract of this content is actually I'm doing the carbon capturing process for recycled coarse aggregate conditioning and also for the concrete curing. This is the basic thing. In this review paper, what we did is it's completely the mechanism how the carbon dioxide just involved in the mechanism process, that is hardening process of the concrete, and how the strength may be. That is the inclusion in this abstract. Next slide. Why we need the concrete carbonation curing? Ma'am, next slide, ma'am. Ma'am, are you getting my words?
Hello, this slide is okay?
Okay, ma'am. Okay, ma'am.
Yeah, you can continue.
I'll say next for the next thing. Okay, ma'am.
Okay, sure.
Okay, fine. Need for carbon cured. Actually, the selection of topic and why the carbon curing is important. Yes, definitely in a cement industry is a major contribution for the carbon emission. That is up to 5 to 8% only from the cement industry. That carbon emission, even from the construction industry, we can capture and we can attain it for the sequestration process. That is how we can go with this carbon curing. Next. Carbon curing of cement based product here will select the different range. That is, one product is recycled coarse aggregate. The carbonation application of carbon conditioning for the recycled aggregate will definitely make an arrangement in high resistance, acid ingress, sulfate attack, freeze and thaw cycle, and also for surface scaling damage also. Carbon curing of cement-based products provides a direct sequestration method, which is geologically stable, environmentally stable, and economically beneficial. Next. Yes. Coming for the introduction, as I explained, same thing, 5 to 8% from the carbon, from the cement industry, it is the carbon dioxide emission. By sequencing that for the respective parameter, we can go for the idea. Now I'll explain in this review paper how the mechanism is and how the carbon dioxide chamber has to prepare for the further studies. This is one review paper regarding this concept. Next, ma'am. Yes, next. This one I explained, Mani. Next. Yes. This is regarding how the carbon dioxide react with the concrete products, which will give a calcium carbonate ettrignite, which makes a concrete dense. That is the initially the concrete recycled coarse aggregates are recommended for 15 to 20% usage according to the making constitution. But now we can increase the quality, or we can increase the attainability of the recycled coarse aggregate usage by conditioning that recycled aggregate is one of the major parameter. That is done, how it can be done and how the chamber is to be prepared. Next slide, ma'am. Yes. This is very important step from the reference of 10 to 12 paper. We will say the mechanism, how exactly the carbon dioxide uptake mechanism will occur in the carbon cured concrete. When we are curing that concrete, this carbon dioxide cured concrete gives a different reaction that will makes a carbon cured concrete mechanically and durably thermodynamically strong. That means calcium hydroxide, calcium silicate hydrates, and calcium sulfur-eliminate reaction, which makes our concrete harden as it is more dense than the normal conventional concrete. These are the carbonation equation when the calcium hydroxide liberation and lichats with the concrete. This is the equations as derived from different papers. These equations will say how the mechanism involved in the carbon dioxide curing, even when it is with the carbon concrete, which is cured by carbon dioxide, and also usage of recycled aggregate inside the concrete. Next, ma'am. Yes. This is a mechanism flow chart of carbon dioxide uptake mechanism, which based on the cement products. Basically, there is no replacement here. Generally, only the normal conventional concrete, but replacement of recycled aggregate with the conditioning process of carbon dioxide is a major parameter. How it reacts? When calcium hydroxide reacts with the carbon dioxide, when it is induced with the concrete, the decomposition of calcium hydroxide leads an equilibrium concentration, that it maintains the pH and OH pore solution. Definitely it attains a pH solution maintenance, which facilitates compensation of volume loss in hydration process, and also the ettrignite formation at the ITZ section. The ettrignite produces a gypsum, calcite, and alumina gel. This three will make the concrete more dense as compared with the normal conventional concrete. That's why I thought to opt as a carbon dioxide curing is one of the parameter for increase the density of the concrete along with the maintenance of ITZ problems as occurred in the concrete. Next slide, ma'am. Yes, this is an behavior action of RCA value, which is hired from the reference paper as compared with the normal aggregate, or that is size of an aggregate, virgin aggregate, that is an initially non-recycled recycled aggregates, and carbonated recycled aggregate. Actually, what I'm going to say is, when we are using this recycled aggregate, the limit is up to 20% is standard when it is mixed with the other constants. But when it is coming with the carbon dioxide recycled aggregate, that means conditioned, it is nothing but conditioned aggregate, what I mentioned in the key factor. This conditional recycled aggregate almost, which acts nearly to the virgin aggregate and gives a good strength. That's why we can recommend this carbon recycled aggregate as per the reference. Next slide, ma'am. Next slide. I'll explain in picture only. Next slide. Yes. This is how, one more next slide. This is whatever the picture is showing. This is the recycled conditioning chamber for recycled aggregates. Here we will recycle the aggregates by pouring the aggregates, by passing the pressure of carbon dioxide from this cylinder to this chamber, including the lid and complete tight arrangement, furnated with an airtight management. There is no extrusion of the carbon dioxide outside the environment. Here the recycled aggregates are cured. Next slide. Similarly, next slide. Similarly, that recycled conditioned aggregate has to be used for preparation of concrete. When concrete cubes are prepared, this chamber has to design. This has to design self-designed chamber. This has to be designed in such a way that there is a vacuum pump. This vacuum pump is important to let off the carbon dioxide after curing, a safety valve to let off all the things, and the management of pressure gauge with a regulator. These are the samples. Once this is set up, arranged, this is the cylinder. This is completely a non-electric. It is completely based on the pressure gauge with the pressure of 500 megapascal. As per the studies, it is 400, 500 like that. With the pressure of that, we will include the carbon dioxide inside the chamber. There, the carbonation process inside the concrete and the carbon gas produced. As per the mechanism, they will produce the products. Here, it will densify the concrete. It will lock the concrete porosity, that is impermeability. Permeability of the concrete is good. This is how we will take this concept. Next slide. Next, ma'am. Yes, this is how we'll consider this concept. I'm a PhD scholar from Reva University. I'm doing the PhD on this only. That's why I made a review paper on this. And this environmental impacts and its utilization. Definitely, when we are doing with all these things, we have to concern on socio-economical parameter. Definitely, it is very good for all the credentials, and it is going to be in a cost production. Definitely, it is important. The formula from the reference will made a formula for this PHR by W into alpha, where P and H are the constants, what we are recommending for consumption of energy, and alpha is the efficiency of CO2 sequestration. W is a value corresponding for the cement material with capacity of 1 ton will made reduce for the whatever we are taking in the respective manner. Next slide, ma'am. Yes, this is the flow chart. Finally, what we need. Emission of carbon dioxide in the atmosphere, we can have a multiple option to sequestrate that flue gas can be captured in different way. But my motto or the thought is captured carbon dioxide can utilize for our concrete works. That is captured CO2 stored for further uses. Carbon dioxide curing on cement based product we are applying, then definitely it will show a result of economy in construction site. Next one. Yes, whatever we are doing the work now, it should be on future investigation, how it can extend. Yes, definitely it can extend for techniques which are have to added utilization of carbon dioxide, different more techniques for sustainability, and carbon dioxide cured concrete can be applied in precast elements in a proper way and can be used in a speed construction, and sequestration is done according to the usage of CO2 for curing process itself create a scope. Yes, definitely the curing process itself create a scope for environmental and social benefits. Next, ma'am. Yes, on behalf of that, the conclusion for this review paper, mechanism involved in CO2 uptake by cement-based materials and conditioning of RCA. That CO2 mechanism of cement-based products, basically there are 3 compounds, that is calcium hydroxide, calcium silicate hydroxide, and calcium sulfaluminates. On making an arrangement or micro structural analysis, we can say the OH balance is maintained, alkali content is maintained within dense concrete. Thus, from the explanation, the final conclusion may be explained that usage of CO2 for the curing purpose definitely leads to a scope for environmental and construction sector. In context of carbon conditioning, a clear explanation is given for conditioning process and gives an effective result for improving the mechanical quality of recycled aggregate, application of that conditional of recycled aggregate. Next, ma'am. These are all the reference. In that paper, I'll give the reference numbers. According to that only, these reference are arranged. Next slide. Thank you. Thank you, ma'am.
Thank you, Arpita. I think you are doing really extensive work,
Yes,
and this is one of the most important, prominent topic that
Yes,
need to be researched for
Yes, ma'am.
better working and better quality of concrete that we get
Yes, ma'am.
and work in. Thank you. All the best.
Yes, thank you, ma'am. Sorry for inconvenience, ma'am.
No problem.
Yes, thank you.
Mapar Abbas, please be ready with the presentation.
Is my presentation visible? Is my presentation visible?
No, that's not yet.
Now?
No. Yes, we can see it, but put it on presentation mode.
Is this visible now?
Yes.
First of all, good morning to all of you. The topic of my presentation is properties of rice husk ash and aluminum slag based sustainable geopolymer bricks. The contents of my presentation are introduction, value of research, materials used, results and discussion, conclusion and references. Various industries produce a lot of byproducts, different types of byproducts, which are ground granulated blast furnace slag, which is the byproduct of steel industry, fly ash, which is the byproduct of coal burning thermal power plant, coal bottom ash, the byproduct of same coal burning thermal power plant, and all other byproducts like rice husk ash. These byproducts, the dumping of these byproducts is very difficult as it involves the usage of land. So to overcome from this problem, we can use these ash or byproduct in the manufacturing of bricks. As we all know that in the manufacturing of ordinary bricks, lot of energy is used, lot of energy is utilized. Like the burning temperature of these bricks is more than 1100 degrees Celsius. So to save the energy and to produce economical bricks, what we are using the byproduct of rice, that is rice husk ash, as a source material in the manufacturing of bricks. The value of this research is that we are saving the energy and we are utilizing a byproduct. That is the main point here. And by the use of silica-rich rice husk ash, we can utilize alumina-rich aluminum slag in this research. This is the main point. These are the materials used. Rice husk ash, as I told earlier, that is the byproduct of rice. Rice is a staple food grown all over the world, and the 25% of husk is produced from the rice, and from that 25%, 20% of ash is produced while burning the rice husk. The composition of the rice husk ash depends upon the temperature of burning and the burning condition, because the burning of rice husk can take place in the field or in the factory. And the aluminum slag is the byproduct of aluminum industry. Here we are using alkaline activators, which are the blend of sodium hydroxide and sodium silicate. Other alkaline activators are also available in the market, which are potassium based, but that are costly. These sodium based, sodium hydroxide and sodium silicate are cheaper than potassium based alkaline activators. These are the images of the samples. This is unburned RH, and this is partially burned, and this is fully burned RHA, and this is the image of aluminum slag. These are the physical properties of RHA and aluminum slag, and this is the chemical composition of RHA. Sorry, this is aluminum slag here. I don't know why this is error. RHA is rich in silica. More than 90% of silica is present in RHA, and more than 65% of alumina is present in aluminum slag. For the production of geopolymer concrete, what we need is alumina and silica, because in the conventional concrete, ordinary concrete, calcium silicate hydrate gel, CSH gel, is produced, which hydrates the cement and make the bonding between the aggregates and the cement paste. But here in geopolymer concrete, the formation of aluminosilicate hydrate gel is the main backbone in the polymerization of geopolymer concrete, which binds the aggregate and source material together. Because here we are not providing any kind of binding material, except we are providing rice husk ash, alumina slag, and alkaline activators. The molarity of sodium hydroxide was kept as 8 molar, 10 molar, and 12. The main combination here is we have to keep silica to alumina ratio from 1 to 3, because if there will be a good proportion between silica and alumina, then chances of formation of aluminosilicate hydrate in geopolymer concrete are very good. So we are providing 3 ratios here. Silica to alumina, 3 ratios here, 1, 2, and 3. For the preparation of specimens, all the dry ingredients were mixed together, and then the liquid part, which was the blend of sodium hydroxide and sodium silicate and some water, was mixed with the dry ingredients in two halves. First half is added, then it was mixed, and then second half was added. Then it was thoroughly mixed again till the mixture became homogeneous. Then the molds were cast. Total 54 specimens were cast here. Ambient curing conditions was followed. There was not any water curing. All the specimens were cured in air. These are the mixed proportions of the ingredients which were used here. Here, I have followed my own mixed design, as I have the publication on that. Price has cash based geopolymer concrete optimum mixed design. I have followed that, and from that, the rice husk ash was used at 500 kg per meter cube in all the mixes, and these are the quantities of sodium silicate, sodium hydroxide. Here I have, which I have told earlier, that I have take 3 proportions of 3 molarities of sodium hydroxide and 3 ratios of silica to alumina 1, 2, and 3. These are the designation of mixes based on the silica to alumina ratio and molarity of sodium hydroxide. Then coming on the result and discussion part, what we have found that 2Rb12, which means that silica to alumina in the rice husk ash and alumina based bricks and with molarity of sodium hydroxide as 12 have got highest compressive strength for 7, 14, and 28 days. The 28-day strength was more than 11 MPa for the rice husk ash based brick. Same happened with the bulk density. The bulk density was also maximum for 2Rb12, for which silica to alumina ratio was kept as 2 and sodium hydroxide molarity was kept as 12. Here open porosity was done to know the quantity of pores in the mixes. Here what we have seen that the quantity of pores in the mix 2Rb12 was lesser than all the mixes, and in the control mix and in the mix which was having silica to alumina ratio 1 and sodium hydroxide molarity 8, the quantity of pores was maximum, which was as 0.5. Then after that, water absorption test was done, and here also the water absorption by the mix 2Rb12 was lesser as compared to all the mixes and was greater in the mix 1Rb8 as compared to all the mixes and 3Rb12 as compared to all the mixes. Now coming on the acid attack, in acid attack what we are seeing the weight loss of the mixes, weight loss of the specimens. The specimens were immersed in the HCl solution for 12 weeks, and after every week the solution was changed, 1% HCl solution was changed, and the specimens were weighed, and then after that the weight loss was found out for 12 weeks. What we have seen that the 2Rb12 have got the lesser weight loss as compared to all other mixes for first 3 weeks, but the mix but the mix 3Rb12 have 1Rb8 have got a lot of weight loss in the H1% HCl solution. These are the conclusions, and we can see that compressive strength was 8.2, 10, and 11.2 MPa for 7, 14, and 28 days for the mix 2Rb12, and high bulk density was seen, which was 1120, 1300, and 1600 kg per meter cube, and low porosity of 28%, which is lesser than all other proportions. Water absorption test was done in 2 types of waters, which was normal water, cold water, and hot water. It was seen that the mix 2Rb12 14% and 16% water was absorbed, which was lesser as compared to all the mixes. The reduction in weight after 12 weeks of immersion in 1% HCl solution was lesser, which was only 20%. Therefore, is acid resistant as compared to all other bricks with different SI by AL ratios and NaOH molarity. These are the references. Thank you.
Hello.
Hello.
Bas, can we go to your conclusion slide?
Yes, ma'am, definitely. Just give me 1 second. What's that? Wait, ma'am. Is this visible, ma'am?
Yes, it is.
Yes.
So, if I ask you as a researcher,
Yes,
please be on that slide only.
Hmm.
As a PhD scholar, right?
Yes, ma'am.
So, taking these conclusion in mind, in which direction your research is going to be conducted now?
Ma'am, actually, I'm working on geopolymer concrete, which is rice husk ash and basalt fiber based. So I am in the same field of geopolymer concrete. I just want to cut down the use of cement, as in the production of 1 ton of cement, 0.53 to 1 ton of carbon dioxide is produced, which is a threat to our planet because it increases the greenhouse effect and which will lead to the global warming. That's why I really want to cut down the use of cement, 100% use of cement. That's why I'm working on the geopolymer concrete.
Yes, that I can understand. So your recommendation that for the environmental purpose,
yes, ma'am,
we need to go for some kind of alternative, right?
Yes, ma'am. There are certain alternatives: GGBFS, ground granulated blast furnace like silica fumes, fly ash, coal bottom ash. They have a lot of byproducts. And today in the geopolymer field, all our byproducts are utilized, but practical application is very less. Practical application of this geopolymer concrete, geopolymer bricks is very less. In the market, there are only fly ash bricks available, not any other bricks.
So I wish you all the best for your PhD.
Thank you, ma'am. Thank you so much.
All the best. Thank you.
Thank you.
Viva, are you there?
Yeah, as I've told on behalf of me, my co-author will be presenting it. Ramchandra P will be presenting.
Okay. You can start your presentation and please keep the timing in mind. You have only 10 minutes.
Sure. I'm audible now?
Yeah, you are audible.
Okay. Is my PPT is visible?
Dr. Priyanka, can we go a little faster because the time is already passed by, like it's already 11.
Yes, ma'am, we will do it faster.
Right now? Who is the coordinator?
Ma'am, myself Shivangi, we are coordinating. Now we'll go faster.
So how many scholars or researchers are left for presentation?
Ma'am, him 3 more are there.
Including
him, 4 are there.
4 are there. So
yeah.
Okay, so can we go a bit faster now?
Yeah, fine.
Yes, you can start. Your presentation is visible.
Yeah, fine. I'm audible, ma'am?
Yes.
Yeah. Okay. Good morning, all. I'm Ramchandra, Assistant Professor from the Department of Civil Engineering, PS University. So today I would like to present my paper, Experimental and Prediction of Properties of Concrete Using Steel Slag by Taguchi Method. So I thank my guide, Dr. P.S. Niranjan, Professor and Chairperson, Department of Civil Engineering, the New Horizon College of Engineering. And I would like to thank my co-author, Vibha N, Assistant Professor from CMR University. And I also thank the entire team for accepting our paper and making to present on this particular platform. So thank you so much. So these are the contents of my presentation: introduction, problem formulation, methodology, results and discussion, conclusion, and references. I won't take much time, so I have skipped the literature review. So as you all know that the concrete is the second most consumed substance on the earth after water. So we are mainly focused on this particular concrete product. So annual per person consumption of concrete is about 3 tons. So here I'm concentrating on the products, byproducts of steel slag, granulated blast furnace slag have been tried and tested successfully. So basically, these are the waste which we are produced tons together every day. So it is very important to reuse these particular materials in our construction field. So then effort has been made to use these particular materials in the production of construction materials, which leads to sustainable and green environment. So limited studies have been done in the usage of steel slag as a partial replacement for river sand, and it has been used effectively. So this is how the process of making the steel, as you all know that. So according to the World Steel Association, so more than 400 million tons of slags are produced annually worldwide by the steel as well as the iron industry. And here you can see the different types of steel slag, which are used both as coarse aggregate and fine aggregate. And over 12 millions of tons of steel slag has been produced annually. So we can just imagine, so what is the quantum of slag has been obtained from the production of this particular steel. And storing these particular wastage is a big task. So hence, many researchers have been pointed out in order to use these particular slag effectively in the production of this particular concrete. So as our session chair, madam, has raised this question with respect to the application point of view, Dr. Charu madam, here are a few applications of the steel slag, so which has been already effectively used in the JSW. Okay, so this Jindal steel is in Tornagar, Ballari district, Karnataka. So many researchers have been done on these particular slag, and they have effectively used these particular steel slag in these paver blocks, plasterings, roads, and floorings. So here all we can effectively use these particular products. Okay. So here we can use flooring for heavy loads. This GGBS, one of the author has been produced on paper on this particular GGBS. So we can use in flooring the heavy loads this particular GGBS. So we can use the usage of paver roads, steel slag. So this uh, fine aggregate, which has been obtained from the steel industry, ground granulated blast furnace slag as a fine aggregate, have been effectively used, and it has been implemented in the code also. We can use the percentage of fine aggregate in this particular constructions. So here all based on my interest, I have collected few slides and I have added right now. And so here some of the activities like village roads, canteen building, and pavements. So all these areas where they have used this particular slag and got the good result. So this is the blast furnace slag used in the village roads, so in Bijapur district, Karnataka. And we can use this particular slag sand for the plastering purpose. So we have a Nirmiti Kendra administration block in Ballari, so where they have. So here you can see this is the what the slag sand which have been used for the construction in the plastering purpose. So here these are the few pictures. So like this, we have n number of applications that we have been used for the coarse and fine aggregate. So coarse are less actually. So fine aggregate has been effectively used. So here I have used both coarse aggregate and fine aggregate of steel slag in my research work. So here the characterization of steel slag for the physical and chemical properties, and to examine the slump value and degree of workability of concrete, replacing both natural aggregates by different proportion of steel slag, and what will be the influence in the variation of coarse and fine by compressive strength, split tensile strength at the room temperature. And what I have introduced in this especially is to predict the pressure hardened properties of concrete by Taguchi method. So here basically we can predict what will be the percentage, what will the exact compressive strength and split tensile strength by this particular approach called Taguchi method. So these are the properties of coarse aggregate as well as fine aggregate. We can see the coarse aggregate values, impact value, crushing value, abrasion value, as well as with respect to the steel slag. One thing we can make a point on this particular thing is, so here if you see the coarse aggregate, so density might be the little bit task in order to see, whereas the steel slag density has 2032, whereas the density of natural coarse aggregate one is 1654 kg per meter cube. So this is one thing we need to take care. So due to the metal waste from the heavy load, heavy iron ore. So here the slag, steel slag, the coarse aggregate density is more compared to the natural coarse aggregate. So here we can see the river sand as well as slag sand. So as you all know that the river sand, we are not getting the river sand, we have stopped. So we had been depending on the manufactured sand and this particular slag sand. So we had taken the fine aggregate completely replaced with the granulated blast furnace slag, and we have used the coarse aggregate as natural coarse aggregate in the replacement. So we had been 11 mixes. So
So,
starting from M0 to M10. Yes. Hello.
Ramachandra sir.
Yes, sir.
Hello.
Hello.
Sir, actually,
I'm
your time
audible.
has exceeded for presentation. Am I audible,
What's
sir?
that? Yeah.
Sir, your time has exceeded for presentation.
Yeah. I will conclude, sir.
Yes, sir. Okay, sir.
So these are the cubes and cylinders for the specimens, and here we have the slump value. So coarse aggregate replacement. Here we can see as the percentage of slag increase, the slump value is also increased. And here we can see the prediction of slump value by using this particular Taguchi method. So next is the compressive strength. So compressive strength is also keep on increasing with the percentage of increase in the steel slag, where you can see the 60% of steel slag which has been used has been given the good strength. So this is the prediction value for the compressive strength. And coming to this particular split tensile strength, so we got for the 100% replacement with good percentage of tensile strength. So this is the results for the split tensile. So basically this Taguchi method use the fitted plot curve where exactly we can stimulate the results or predict the results of these particular conclusions. So coming to the conclusions, as the amount of force aggregate replaced, so increase in the slump value, flow drops. However, 10% of steel slag exhibits maximum slump. And coming to the decrease, the density decreases as there is a rise for the proportion of replacement of steel slag. And the compressive strength gives for 60% we got the good compressive strength. And coming to the split tensile strength, so we got 100% replacement for good tensile strength, split tensile strength. So this is how exactly the conclusion results for the both compressive strength, split tensile strength, as well as the workability strength. And these are all my reference. Thank you. If we have any questions.
Thank you, Mr. Ramachandra. I think it was a very intensive presentation. And all the best to you. Thank you. I think we can go to the next.
Yeah, thank you.
Kuldeep Soni, are you there? Kuldeep?
Yeah, ma'am.
You can present now.
Ma'am, I have a little problem to share a video.
Can you repeat what you're saying?
I have a little problem to share video.
Okay, okay. Till then, Nikhil, are you there? Nikhil,
Yes, I'm there.
yeah, you can present.
Sure. Just a second.
Hello, ma'am.
Yeah, your presentation is visible. Please put on slideshow.
This is Kuldeep Soni. I'm a student of MTech in ITM University.
Can you put it on slideshow?
ITM.
Ma'am, this is visual.
Okay, no issue. You proceed.
I am Kuldeep Soni, student of ITM University, MTech. My topic is use of stone dust and ceramic waste in fine aggregate and replacement in RAC. The construction industry is based on concrete structure. In other words, concrete in playing a very important role in modern construction. It is a homogeneous compound of coarse aggregate, fine aggregate, and cement. Conventional concrete made up of conventional materials such as stone chunks are used as coarse aggregate. The coarse aggregate imparts strength to be concrete mixture and reverse and used as the fine aggregate used to fill the voids of coarse aggregate and makes the homogeneous mix and make the binding material like cement lime used to bind this mix by filling the void of fine aggregate. Water makes a chemical combination with the cement and bind the complete concrete matrix. Need for sustainability in construction. Construction is to fulfill the present need without compromising further needs, but continuing organizing of natural resources can be big threat to construction sustainability, so that the construction industry building scrap comprise numerous kind of strong like broken concrete from pieces of pillars and columns, broken chunks of bricks and stonework, wooden squander, ceramic squander, etc. Ceramic squander are board category, and rudely glow ceramic squander and white glue ceramic squander and rudely glue ceramic squander comprised fabric and brick tile and burnt clay. Military and white glue ceramic squander comprise porcelain fabric like a china clay material. Ceramic waste can be great choice to supplant routine fine aggregate due to its inactive nature, less water assimilation, and great particular gravity. This consideration comprise to test investigation of fine total substitution with 100% stone dust At that point, stone dust somewhat substitution by ceramic based as 10%, 15%, 20%, 25% for quality and toughness analysis. Strength exam is done with compressive as well as flexural quality test and burgability test.
Kuldeep, your slides are not moving. Please check once. You're still on content page.
Ma'am, is this correct?
Introduction is coming now. Literature review. You can skip your literature review and come to your work. Yeah, you can start from here.
This results is an experimental approach in this study, complete replacement of a conventional fine aggregate with stone dust and ceramic waste is done. This study is done in two stages. In the first stage, conventional aggregate replacement is done with stone dust completely, and the next stage, stone dust replacement with ceramic waste is done partially at 0%, 10%, 15%, 20%, and 25%. The use of stone dust and ceramic waste has great potential to replace the conventional fine aggregate. This replacement shows the three directional boons to society and helps to achieve a sustainable future in the construction industry. As an alternative to conventional fine aggregate leads to protecting and saving the natural resources of a conventional fine aggregate. It controls solid waste accumulation due to waste and further alternative material, or we can say give drive material. Complete replacement of stone dust make concrete little stiff and weak due to decrement of slump value by 3 mm and drop in compressive strength by 2.42%, but these value are comes under the permissible value. Therefore, complete replacement of conventional sand can be possible with stone dust. Replacement by stone dust by ceramic based leads to increment in the compressive strength up to optimum value of replacement 20%. At the point of optimum replacement of stone dust with ceramic based, compressive strength is an increment of a maximum of 16.3%. But the workability of a concrete decreasing with the ceramic based increment in the concrete. The workability of the concrete lies between 20 to 50 mm. Therefore, this concrete is recommended for the mass concreting work with vibration. Workability drop in concrete concern of increment of ceramic waste. Therefore, this replacement can be possible in self-compacting concrete. The optimum value of ceramic waste is achieving by 20% with stone dust. In recycled concrete, complete replacement of of a conventional fine aggregate by stone dust and ceramic waste is possible to achieve strength as per mixed design. This research work conclude as there is good potential of the ceramic waste as a conventional fine aggregate and stone dust in concrete production up to 20%.
Thank you.
These references are used in this is this visible, ma'am?
Okay. Yes. Can we conclude? Okay, thank you. Can we go to the next presentation now?
Nikhil, are you ready? Nikhil?
Yes, I'm ready.
Yeah, just present.
Yeah, sure.
Is this the last presentation now?
Yes, ma'am. This is the last one.
Okay.
Okay, is that visible? Hello, is my screen visible?
Yeah, it is visible. You can start.
Good morning, all. Myself, Nikhil Murray. I'm from Indira College of Engineering and Management, Pune. Today, my topic of presentation is impact of engineering properties on concrete after full replacement of cement with GGBS in addition of NaOH. These are my contents: introduction, problem statements, objectives, methodology, and all. Now, what is basically the construction industry give us? As you can see, in last 10 years, construction industry has raised almost from 2,300 billion Indian rupees to 3,300 billion million rupees. That means almost 1,000 billion rupees Indian rupees have been increased from last 10 years, which shows that the second most raise which industry have performed. But due to the raise, we also have some economical and sorry, not economical, some environmental problems as well. Like production of cement gives the almost second largest amount of CO2, which emits second largest amount of CO2, and that too is not that much. As you can see, 5 to 7% is not that much amount, but still 5 to 7% is compared to other industries is a huge amount, which gives carbon dioxide. Also, like I'll be doing a bit faster. Also, some industrial manufacturing companies like steel industries and iron industries gives GGBS as their base product. GGBS is then either being dumped somewhere or being used in also cement, but that will be in very small amount. But where maximum amount of GGBS is being dumped, that dumping land can be further used for say vegetations, forestations, or just if I consider the green belt, it can be used for many other purposes. I'm not considering the residential areas or the industrial areas. I'm just considering the green belt. That much amount of land has been waste for dumping every year. So what should we do? The least considered thing should be a landfill part. But the first considered thing, what practically we do is landfilling. We don't recover, we don't recycle, we don't reuse, or we didn't even reduce it. We didn't even reduce, or we can't reduce the GGBS because it's a waste product. We need steel, we need iron, so it is going to be there. Also, for cement, also we can't reduce constructions, or we can reduce the infrastructure development of our country. So basically, we have to find a replacement for the cement industry just to like just to reduce the carbon emission and also to reduce the landfilling. So I proposed GGBS to be the 100% replaced material for in the construction industry in concrete. So my problem statements are like cement releases the CO2 in air, which affects the environment. Also, the construction industries which are growing have very much ill effects on the economic, because it is a costly purpose. It is a costly industry. Every meter cube of concrete which has been made takes around 6 to 8,000 rupees, which is a huge amount. So it is also a costly part. Also, GGBS is a byproduct which is coming from the molten iron slags, uh, affects the agriculture and everything. So what are the objectives which I did? It was like to utilize the waste, then to replace cement with GGBS, to obtain the strengths, the results of 100% replacement of GGBS, and also to provide an economical construction materials. Now, what are the methodologies? Say these are the methodologies. I use M30 as the base product or as the base mix, because most of in Pune, most of the industries use M30 mix for their construction purposes. My experimental work started with dry mixing of the materials. The materials which I used were GGBS aggregates, that is fine and coarse both, and NaOH. Now NaOH is the content, or is it acts as an admixture which increases the hydration process, which GGBS with water cannot have. I just I just made 3 different mixes which has NaOH. The difference between them was the molarity of that the solution, the concentration of that solution. I used 10 moles, 15 moles, and 20 moles, as I have read in many literatures that the molarity should be greater than 8, but should not be more than 20 or 25. So I just utilized these 3 molarity concentrations. The different thing which I did, which I performed, was none of the researchers have previously used 100% of GGBS, so I just used it as a 100% replacement. That too with these 3 concentrations. These were the casting specifications. I casted 7 cubes of each mix. You can see in the table, mix 1 stands for the conventional concrete, which has cement, 0 GGBS, and 0 NaOH. Whereas in M2, M3, and M4, we have 100% replacement of cement with GGBS, and also according to the molarity, we have the volume of your NaOH. And I also tested some beams for the flexurity test. These were the flowcharts of cube casting. As you can see, 35 cubes of each mix were casted, 7 cubes of each day, 7th, 14th, 28th, 90th, and 365th day. Similarly, 25 beams of each mix were casted, like 5 beams for each day, 7th, 14th, 28th, 90th, and 365th day. Cube casting was done, beam casting was done. For compressive strength, CTM was done. CTM testing was done with a capacity of 250 tons. UTM was used, which is having the capacity of 60 tons. And these were my results. As you can see, for the conventional concrete, as I said, I chose M30 mix. So on 20th day, my strength was 31.5. As you can see over here, my strength was 31.71. As the day increased, like on 90th day, it became 33%, 33, and on 365th day, it became almost 95, almost 35. But as you can see, the increase in strength from 7th day, that is from 21.10 MPa to 34.91 MPa, the increase in strength was almost 65%. Now, if this is what the conventional concrete gives us, but whereas if I see the M2 mix, that is the NaOH content having 10 moles, similar things were seen, but the increase in strength was 76%. Though the strength of 28th day was less, I agree, but if we required, say, mixes for pavement constructions or block contract constructions, we can use this kind of mixes, because though some blocks have M10, M15 or M20 strengths, we can design it for M30 mix and can achieve M20, M25 strengths. But as you can see, as the curing day increases, the strength which achieved as a target strength. But as I went on increasing the molarity, the percentage increase was less. Also, the 28-day strength was less. And the 365-day strength was even lesser. So these are my results. You can see in the form of graphs. The red line stands for mix 1, orange stands for mix 2, the brown stands for mix 3, and blue stands for mix 4. These are all results of compressive strengths. Now, these were the results of flexural strengths that I casted beams and then conducted tests on it. As you can see, mix 1, the 20th day flexural strength was 5.30. The 365th day, that is 1 year strength, was 6.08. The increase was 80%. But in mix 2, again, the increase was 82%. So in both the tests, like say for compressive as well as for flexural, the M2 mix stands superior compared to what the increase in strength is considered. Though the instantaneous strengths were lesser, but we can just compensate.
Nikhil, if
Yeah?
you can please be faster.
Yeah, sure. These were the results. So I'll quickly jump on the conclusions. Like mixing GGBS or mixing NaOH with GGBS, the concentration, as the concentration increases, the workability reduces. If I'm mixing M10, the workability is a bit reduced. If I'm mixing say 15 mole concentration, the workability is more reduced. As I went on increasing the molarity, the vocabulary reduces. So it accidentally became a rapid hardening concrete. Then lower NaOH concentration gives better results, both in compressive as well as flexural. As compared to conventional concrete, curing can be expanded, or curing is not even required because hydration process is not actually happening in GGBS concrete. So you can use this concrete, or you can use this structure without curing it. Next conclusion was, amongst the modified concrete, that is the GGBS concrete, the 10 mole concentration results were best. Then if I'm suggesting to replace the cement by 100%, we have to go to adopt a higher proportion of mix design, so to achieve for the target strengths. And also the cost of construction for every meter cubic concrete or conventional concrete, GGBS reduced the cost from 16%. That is 16 to 20%, because compared to what GGBS class you're using and what NaOH concentrations you're using. So that was all. References I have already mentioned in my paper. So these are the references. Thank you.
Yeah, before we go for the question answer session, we welcome our session chair for the next session. Dr. Altaf is with us. So a very good afternoon to you, sir, and welcome to this session.
Yeah, good afternoon everyone.
I think
And
it is
thanks.
morning there. I think in India it is morning. Here it is afternoon, so very good morning.
Yeah, good morning to everyone. Yeah.
Yeah, good morning. Now we can go for the question and answer session. Shivangi, is that session over?
Yes, ma'am. If anyone has any question, they can ask. Charu, ma'am, if you have any question.
I must appreciate Nikhil's work. I think he is doing, very relevant research in which the cost is very much affected. And if, as you know, that in today's scenario, cost-effective construction is very much in demand. So I must congratulate Nikhil and all the best, Nikhil. Keep
Thank you,
your
ma'am.
research update and all the best. Thank you.
Thank you, ma'am.
Can I leave now?
Yeah, yes, ma'am, you can leave. Thank you so much for
Thank you so
spending
much.
valuable time for us.
Okay.
Yeah, thank you so much. And Shivangi, there's one more student, international student, and presentation. He has mentioned in the chat box also.
Okay, ma'am, we will check once.
Yeah.
Okay, so now we'll be starting with the next session. And Dr. Altaf is here. Good afternoon, sir.
Yeah, good afternoon, Dr. Shivangi. Yeah, we can go
Good
ahead.
So,
yeah, Shivangi, paper ID. Sorry, Shivangi, paper ID 211 is remaining.
ma'am,
I think
actually,
it is
he's in track 9. He's not in our track.
He is in track 9.
Yes, ma'am.
Okay. I'll just inform.
So Dr. Altaf Usmani is working as Deputy General Manager, Engineering and Technology, Development Division, Engineers India Limited, New Delhi. Dr. Usmani is a lead geotechnical expert in the field of design of underground structures for storage of crude oil, LPG, and other products. Dr. Altaf is actively involved in research aimed at finding underground options for storage of CO2 and use of geothermal energy for energy requirements of buildings. Dr. Altaf Usmani has authored vast number of papers in international and national journals and conferences covering various challenges in the field of soil and rock mechanics, and has also authored a book on underground storage technologies. Dr. Usmani is a recipient of several awards, including Young Geotechnical Engineer Award 2010 from the Indian Geotechnical Society, Delhi chapter, and Best Member of TC 204 of International Society of Soil Mechanics and Geotechnical Engineering on underground construction in soft ground. Dr. Usmani is also a key member of IS Code Committee CED 48 Rock Mechanics Committee and is the co-chairman of Indian Geotechnical Society, Delhi chapter. We welcome you, sir.
Yeah, thanks for the introduction. Yeah, thank you.
Thank you.
Yes, Shivangi, we can go ahead with the paper presentation of paper ID 211 in this session.
Okay.
And then we will move to the other students.
Okay. So I request paper ID 211 to start your presentation.
Thank you, Ms. Wangi. I will share my presentation slide. Can you hear me and see my slide?
Yeah, your slides are visible.
Okay. Okay, good afternoon, everyone. I'm so sorry, maybe I mistaken on the room. So I will present the paper on behalf of the researcher. So our paper is about socio-economic impact assessment of dam rate, a case study of Hulu Perak dams in Malaysia. So nice meeting all of you. So This is our content. It's about the introduction, problem formulation, literature review, study area, result and discussion, conclusion, and also references. So as we know that dams have long been acknowledged as one of the key infrastructure that have been benefited mankind for centuries. For example, for domestic and industrial water supplies, irrigation, aquaculture, hydropower, recreation, and also water retention and flood mitigation. However, despite of the being well structured and beneficial to the others, sorry, ma'am.
Am I audible? I'm sorry, I lost my internet in between and I had to join from other place. Yeah. So am I audible? I'm happy to answer any question. Yeah. Yeah, sure. Dr. Nidhi actually.
Rafida, you can continue with the presentation.
Okay, thank you. So during our aging and we have reached the end of their design. Intended lifespan as their design lifespan is only around 50 to 100 years only. So what made the cause of the dam break is for the due to the climate change, which is unforeseen heavy rainfall and landslide, earthquake, and also firmament. And also what is the consequence of the dam break is first is fatal cases and loss of lives. Second, it devastating effect to the environment, and also it incurs high social and economic costs, especially for the downstream communities. So for the purpose of the research, our research especially is to assess the socio-economic impacts of flooding due to dam breaks in Hulu Perak District, Perak State, Malaysia. So the objective of this study is to quantify the extent of the damage and displacement caused by floods and their immediate impact on the community in the residential area, public infrastructure or facility, and also the heritage and cultural sites. Okay, this is the overview of the dam break incident throughout all the words, which is the Marit Dam, Eaton Dam, also Fergau, and nearby to our neighboring country is Ginto and also Ella in Indonesia, which also effect to the loss of life and also give more effect to the downstream areas. Okay, so for our focusing in our research, which is the implication of dam break indexes of socio-economic impacts, it started from the risk population, go to the public facility or important facility, and then effect also to the culture, heritage sites, and the last one is due to the, all the dam break effect go to the ecosystem. Okay, this is our study area in Hulu Perak dams. There are three dams, which is dam A, we call it Temenggo, also Bersia and Canary. So as you can see in the figure, there is a dam in Hulu Perak, and then this from the Google Pro, we extracted it. So we can see the view from the maps and also the live view also from the Google Pro. Okay, so what we are discussing about is the socio-economic impact risk assessment in focusing on Hulu Perak. As we can see in table 1, the Hulu Perak population that will be affected by the dam break is more than 80,000 people. And then for the table 2 is this all the list of the important public facility that we have in Hulu Perak. For example, community hall, post office, food court, and also we can see in table 3 is main focus and tourism activity, the international gate, mining heritage, natural heritage, and also world historical heritage. And the table 4, which is we category on the tourism product in Hulu Perak, which is natural attraction, and also man-made as like sport and recreation, shopping mall, and also agro-tourism. So we can see that all of this will be affected by the dam break in Hulu Perak. Okay, for the economic impact, we can see that for the Hulu Perak district only, it will affect and give the estimation from the GDP is more than 1,000,000. And then for all the Perak state is only 39 million. So it's give a big contribution if the dam break is having failure in Hulu Perak. Okay, so just a brief conclusion that Hulu Perak is one of the districts that has significant contribution to socio-economic activity, especially in ecotourism and forest activity. And most of them is indigenous community. And we also, the dam is confluent with the joint river Sungai Perak. Hulu Perak has been identified as one of the districts with frequent record of flood disaster, and each even recorded 11 cases of flood in 2020, mainly due to the flood, flash flood we happened because of heavy rain during that time, especially in monsoon season. And hence, this district has been identified as a high-risk area in Perak because previous flood disaster as reported show that there is a failure in notifying the community with sufficient preparation and evacuation. Therefore, its impact occurrence of flood might cause heavy damage to the socio-economic of Hulu Perak. Hence, as I can conclude that there is a need for the authority to make early preparation and mitigation plan in order to ensure that especially during the monsoon season, we can control the water and we can control the flash flood and make sure our dam in a good condition, so that everything can be in the control. And the last one, it can risk the minimize the risk to the downstream area. So this is the reference list that I have gathered from all our study and from the Malaysia itself, and also to the overall work. I think that's all. Thank you.
Thank you so much. Altaf sir, you can ask questions from her.
I think I have no questions in this paper. Oh, that's okay.
Okay, sir. Okay, sir. So next we want to invite Afrin. Are you there? Afrin Khan?
Yes, ma'am. Am I audible?
Yeah, you can share your PPT now.
Yes, ma'am.
Excuse me, ma'am. Hello.
Hello.
Ma'am, can I present after this? Actually, I've been waiting for a long time and I am in my office currently, so I won't be able to present much later.
Can you tell your name?
Anmol Niranjan.
Anmol. Sure, you can present it last.
Can you repeat? Can I present after this?
Yeah, sure, you can do.
Yeah.
After you can start now.
Is my PPT visible, ma'am?
Yes, it is visible.
Good afternoon, everyone. I'm Afreen Khan, and I'm here to present my work on the topic of numerical analysis of edge-shaped Barrett files subjected to vertical and lateral loading. My co-authors are S.W. Thakre sir and Dr. A.I. Dhatrak sir. I am currently pursuing MTech from Government College of Engineering, Amravati. Hello. Hello.
The slides are not moving, I think.
There is certain problem, I think.
Please unshare and share again.
Okay, ma'am. I think, ma'am, there is problem. I'm not able to share the screen.
Okay, we can go with the next. Anmol, are you there?
Ma'am, actually, mine paper ID is next 181.
Can I present now?
Ma'am, is my screen visible now?
Yeah, it is.
Yeah, it's now visible. You can go ahead.
And are the slides changing?
No, it is still on the first.
Afreen, put it on slide mode.
Yes, sir.
It is on the first now. Actually, you can do after this, okay? If you are having any network issues.
No, sir, ma'am. Actually, it has started.
Okay, you try once more. Your screen is visible, but your slides are not getting changed.
Is the slides changing now?
No, it is on still on the first only.
I'm not getting what is the problem.
You just WhatsApp your presentation, no? So that we can proceed next.
At the group?
Yeah, group, or you can personally send me, okay?
Okay, ma'am.
We'll call you, okay? Next. Pravesh Kumar, are you there?
Yes, ma'am. Yes, ma'am. Paper
Yeah.
ID 181. Ma'am, I
Yeah,
have sent the PPT to Nipun Pratap Singh.
Yeah. We'll present. You can start now.
Hello, can I start, ma'am?
Yeah, you can start and you tell next, so we'll do next.
Okay. Good afternoon to all of you. I am Dr. Parvesh Kumar, and the topic of my presentation is effect of jute fiber on engineering properties of soil. My co-authors are Mr. Fayaz Ahmed Mir, and I am Assistant Professor in Department of Civil Engineering, Lingyas Vidyapeeth, Haryana. Ma'am, next slide, please. Hello. Hello. Starting with the introduction slide. So jute fibers are the Hello. Ma'am, I'm audible?
Yeah, you are audible. You can go ahead, Pravesh.
Okay. Jute textiles, as the name suggests, it is made up of jute plant, and its cultivation is done in the Ganga Brahmaputra Delta from centuries. Actually, jute fiber are of two types: natural fiber and synthetic fiber. So, please next slide. Next slide, sir. So, starting with the literature review, the first use of fabric structure for geotechnical engineering in 1926. Then in 1930, it is used as a woven jute fabric. In 1983, Gray and Ohashi conducted a series of direct shear tests on dry sand to evaluate the effect of parameters on the shear strength of the fiber. Then Singh and Wangra in 2013 conducted an experimental study on Itanagar soil, and basically the CBR properties of soil are determined. So with the effect of the diameter and the length of the fiber on the subgrade properties. And then Das Gupta in 2014 carried out an experimental investigation to enhance the characteristics of soil by addition of jute, and concluded that there is a crucial variation in CBR value when the jute fiber is added. Then Hassan and Rayan in 2014 carried out a study to determine the effect of fiber geometry on the properties of soil, and found that there is a significant effect on the geometry of fiber on the soil properties. Kumar et al. In 2015 and Kumar and Mir in 2017 carried out a study on enhancement of CBR ratio, and found that the amount of jute fiber in dry weight of soil is determined in increment of 1%, and without taking fiber diameter into account, the length of jute fiber were assumed to be 20, 40, 60, 80, and 100. So coming to the problem formulation slide, in the present study, 3 parameters are checked. Basically, the first, the UCS value of the soil when it is unreinforced and after reinforcement, and then the CBR's subgrade characteristics of soil in unsoaked condition, and then in the soaked condition. So then material used, the soil used in this project is from Pampore site near the J&K highway, and the soil is taken from 2-meter depth, and the jute fiber is used as a reinforcing material. And these are the properties of the soil. Table 1, these are basic engineering properties. And then the methodology, then the soil is collected from the Pampore site, then it is pulverized and kept in the oven for 24 hours at 110 degrees Celsius. Then UCS value of unreinforced soil and CBR value of unreinforced soil are determined under soaked and unsoaked condition, and then the jute.
Hello. Pravesh, your voice is not audible.
Hello. Yeah, can you repeat what you're saying?
Shivangi, this is Dr. Altaf. I think Parvesh voice is not audible and his slides are also not changing.
Okay. So we'll check once.
Hello, ma'am.
Yeah, Praveen, you can start. Just skip the literature review and you can go on your work.
Okay, ma'am. Ma'am, yes, problem formulation. These are the major objectives which are covered in the present study. First, we focus on the UCS value of UCS of soil under unreinforced condition and reinforced condition. Then we check the subgrade characteristics of soil under reinforced and unreinforced condition in both the soaked and unsoaked condition. Next slide, please. Then the material used in the present work are soil and jute fiber. Soil is taken from the Pampore site near J&K highway, and it is dug from the depth of 2 meter. And jute fiber, natural jute fiber, is used as we can see in the figure also. Jute threads of 3 centimeter length and are used for the project. Next slide, please. Hello, next slide. These are the engineering properties of the soil: specific gravity, liquid limit, plastic limit. These are the properties of unreinforced soil. So the UCS value of unreinforced soil is 0.87 kg per centimeter square, and the CBR value under unsoaked condition is 3.9%, and under soaked condition it is 2.40%. Next slide, please. Then the methodology adopted in the present study contains, firstly, the soil is taken from the Pampore site, and then it is taken into the laboratory, and it is pulverized and kept in the oven for 24 hours at 110 degrees Celsius. Then the UCS value is determined, and the subgrade characteristics of the soil are determined under both soaked and unsoaked condition. And then the jute fiber is added into the soil from percentage varies from 0.25% to 1%. Next slide, please. These are the results which are obtained from UCS test. As we can observe from the graphs that as the percentage of the jute increases, there is an increase in the UCS value. Next slide, please. This graph represent the increase in the UCS value with the fiber content. When it is at 0% jute fiber, the UCS value is minimum, that is 0.87, and maximum at 1%, that is around 1.16. Next slide, please. These are the graph which represent the CBR value under unsoaked conditions. As we can see that the highest value is obtained for 1% and the lowest is obtained for unreinforced soil. Next. This also this graph also represent the CBR value with respect to the fiber content, and the maximum is obtained at 1% and minimum at 0.25%. Next slide. The conclusion consists of mainly three things: the MDD decreases and OMC increases, which is quite obvious. And then the UCS value of the unreinforced soil is 0.87 kPa, and it increases up to 1.16 kg per centimeter square when the jute is added to 0.5 to 1%. And the CBR value raises from 3.9 to 8.02% when jute fiber is added to the soil. And under soaked condition, the CBR value rises from 2.45% to 5.31% when the jute is added from 0.25% to 1%. And next slide, please. And these are the references which are used in the present study. Next. 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 Thank you. These are the references which are used.
Hello, yeah, Parvesh, can you hear me?
Yes, yes, sir. Yes, yes, we can. I can.
So just we can take few quick questions from you.
Yes, yes, yes.
Tell me one thing. You added this jute fiber up to 1%.
Yes, yes.
So is there any codal provision that you can go up to
Huh,
what percentage?
There is no such codal provision, but I have added the jute percentage based on the previous literature review done by various researchers. So in the literature review, I have found that the maximum has added the jute fiber up to 5%, and less work on is done over 5%. So we have decided to go with the percentage from 0.25 to 1% in an increment of 0.25. So this is based on the previous literature review, because limited work is done on that.
Another thing, with 1%, what about the mixing? How do you mix it? There was some segregation.
Yes, 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 sir. Actually, we have taken the soil from the site. Then we added the water to it according to its OMC, optimum moisture content, and then we add the jute fiber, which are cut into in the form of threads to it. So as we know, jute is a organic material and it will decompose after some time. So we coated it with the bitumen layer so that it can resist for some time, because natural fiber are not durable as compared to the synthetic fiber, but still natural fiber are cheap, easily available. So we can prefer natural this type of jute reinforcement in embankments, and but where the building structure is required, jute reinforcement is not recommended, sir. It is only recommended where the embankment dams is there, because there is a less chance of failure.
Reliability, you can say that for the if we are taking into account long-term reliability of the fiber, it
Yes,
will
yes.
not be so much there.
It will not be, yes, sir. This is the limitation of this work. This is the this is the you can say we cannot rely. It is not reliable. Jute is not reliable as other synthetic fibers are, like geonets, geosynthetic. They are more reliable as compared to. So, but still, a lot of work has been done on natural fiber also, like jute, coir. These fiber are also used to reinforce the soil. So I have also.
Yes, right. This coir and jute are used for like slope protection and other works.
Yes, sir.
So once you are doing in this work, you can also add some kind of practical applications, that how you are going to use this for which kind of works it will be specific.
Yes, actually, sir, this work was based on my MTech work when I was in MTech. So I have taken two soil from different sites there, and I have done the comparative study between the two soil. So maybe in future we can use this as a case study also. Somewhere we can use jute fiber to reinforce the soil. So maybe in its future scope we can cap that portion also.
Yeah. Okay. Thank you.
Thank you so much, sir. Thank you.
Thank you, Pravesh. Now,
thank you.
Can
so
we
much,
have Anmol to present?
Yeah, I'm just sharing this. One second.
Sure, and please try to complete your presentation within 8 to 10 minutes.
Yeah, sure. Just 1 second, I'll have to rejoin to share, I guess. It's asking me to rejoin. I'm just rejoining 1 second. Is it visible?
Yes, it's visible.
Good afternoon, everyone. Myself Anmol Niranjan, and I am here to present my paper, which is on the topic of evaluation of residential housing society in terms of energy optimization and water management criterion of Griha rating system. There are 4 authors: Hardik Sharma, myself Anmol, Ashish, and Hemant. So, as we all know, sustainability in a broader aspect aims for improving the quality of life with a healthy environment without compromising the needs of the future. And basically, it has 3 spheres which are interconnected. Those are economic, social, and environmental parameters. So, we have used the Griha rating system for the assessment of this society. The benefits of Griha are as listed. It decreases the GHG emission and benefits the environment. And there are various other benefits as listed in the slide. We have used the Edge software. The main reason for using Edge is that we are not recommending any changes. We are not recommending any changes in the on-built site. We are just evaluating a pre-built site and just suggesting some changes which can be done at a later stage. The methodology which we have adopted is based on 8 grounds. First is site selection, then water conservation, energy conservation, human adaptation, cost efficiency, selection of sustainable materials, improving life cycle of a building, and use of softwares for better designs. So we have done the case study on a residential housing society in Chhattisgarh. Uh, it has a plot area of more than 5 lakh square feet, and the plinth and slab area as listed above. And the society is efficiently designed to lead every aspect of workability, functionality, sustainability, economic, and aesthetic part of the cycle of a building. The each house is constructed from fly ash based content in the bricks as well as the cement. The energy consumption aspect is also verged by the 4 to 5 star rated appliances, and which is in accordance to ISO 16358. So as we can see that we have tested on various parameters that are lighting, ventilation, and others as well. So in the lighting, we did not do much as there was nothing much to improve on the side. Uh, just that we suggested some changes, like the windows were facing in the wrong direction and there was not sufficient light coming in. So that meant a higher usage of the LED bulbs. So the total energy consumed we have calculated and it is mentioned here as well. The ventilation system is very important. If the ventilation of a house is proper and it is in a efficient way, the fan and the cooling system will work more efficiently and the overall electricity consumption would be much less. So we have also done water management as well. So according to for calculating the WPI, we have basically calculated WPI and moved forward. So for calculating WPI, there were approximately 3 types of houses. Like in one house, there are 7. In some houses, there are 4, and in some houses, there are 3 residents. So we have calculated the WPI for each in each case, and according to the changes which we have recommended, like installation of the smart sensor taps and other water conservation methods. So we can see that this showed a reduction of 11%, and which is very significant if we compare it in a year-long period. So another thing we have considered and suggested is the solar panels. The society was not yet equipped with the solar panels, but they were thinking about it, and we have recommended some changes in their plan of the solar panels as well. One of the things that most people ignore when talking about sustainable development and sustainable construction, to be specific, is the interior part of uh, construction. The interiors we use are not very sustainable. Generally, in most of the homes, we can see that all the materials, they either cost too much or they are not sustainable materials or anything. And we can also change the orientation to help get better sunlight in the winter. And so another trick is like the sunsets or over a roof hang, and by using the materials which are available in your locality. So we have suggested many changes in that regards also. Then we can talk about the conclusion. Like we have studied a multi-story building and various ways to push the building towards a sustainable home. The building study does not have sustainable interior and water harvesting and water conservation practice. And another thing is that we have suggested we have suggested wastewater treatment plant, sewage water treatment plant of about 226 cubic meters, and they have already installed it, and it is also being used to like wash the cars. The treated water is used to wash the cars, and the grey water of all the taps and shower waters are being connected to the sewage water treatment plant. So yeah, we have recommended various changes in the plumbing as well, and in the window specifications, the window placement, the use of ventilations. Uh, yeah, thank you.
Yeah, Anmol.
Yes, sir.
So what I can found out from your study, you are working on some sustainable solutions for home, right?
Yes, sir.
So how this sustainability, how you are measuring, what are the parameters of sustainability?
Sir, we are working on 8 grounds, like the site selection, the water conservation, energy conservation, and we are working on these regards, the main.
And how many case studies you have considered?
Sir, for this paper, 1 case study, but in total we have considered 5 case studies.
Because whatever the conclusions you are getting, it should be at least to few sites, maybe 2 or 3 minimum, to arrive at some data.
So yes, sir, we have studied about 5 sites in different areas of India, and we have made different papers on each site. So this is the paper from the housing society site.
Okay, and this
Yes,
in this one you have not considered anything related to solar, no?
No, sir, we have in the paper, it is there in the present. Actually, sir, I was in my office, so I got the message today morning itself. So I was not able to prepare well the PPT, but in the paper, we have everything related to the solar panels as well. We have recommended some changes as well in the solar panels.
Because that will be an important part when you are trying to have some kind of energy.
Yes, sir. Yes, sir. Even we
requirement.
have told them that the sewage treatment plant which they have installed is generating about 20,000 per month electricity bill. So we have told them to use solar panels to run their sewage treatment plant, to find a way to do that as well. And we have recommended how to do that as well. It is mentioned in the paper.
Okay, I think next time you can have more data and more elaborate presentation. Okay, thank
Yes,
you.
sir. Thank you, sir.
Yeah, next.
Can we have Avanti next?
Yes, sir.
Anmol, please unshare your screen.
Is my screen visible?
Yes, it's visible.
So good afternoon, everyone. I am Avanti Kazarkar, and I am here to and I am currently pursuing masters in geotechnical engineering from Government College of Engineering, Amravati, and from Government College of Engineering, Amravati. Today, I am here to present the work of my project, that is performance of hybrid mud mat foundation for offshore structures.
Sir, is it change slide number?
No, slide is not changing. Still, it is on the slide 1 only.
Is it okay, sir?
Yeah, now it's okay. You need to select it. Yeah.
Yes, sir. Nowadays, the offshore industry has taken lead in advancement of civilization. As a result of that, there are numerous offshore structures worldwide. So, mud-mat foundation are provided for the structures such as pipeline in termination, pipeline in manifold, slate system, and subsea umbilical termination assembly. This figure shows the mud-mat foundation. Then next. Next slide. Next slide, please. But there are some situations such as very poor soil in brownfield site where the space is limited or where the installation vessel limits the foundation site. Mud-mat alone may not provide the adequate capacity. Hence, hybrid mud-mat foundation is found to be useful in such a cases. This system provides greater. It is nothing but a combination of a mud-mat and piles, and this system provides greater resistance to large horizontal load in addition to vertical load and limit the size of mud-mat. Then literature review. P. Demack et al. In 2013 conducted the research on hybrid mud-mat foundation equipment, and they concluded that the significant increase in the foundation capacity can be achieved by adding the short pile to an existing mat foundation by placing them at mat corners. Then M. Kabir Hoshan and others in 2015 carried out numerical analysis of mud-mat pile foundation behavior as a hybrid integrated system, and the mud-mat corner pile mud-mat connection and seabed soil were taken into account in FEM analysis. They concluded that in comparison to sliding connection, the rigid mud-mat to pile connection had more capacity. Next. Then HP Dune and others in 2017 carried out numerical analysis to ascertain the capacity of mud-mat foundation and hybrid foundation in clay. Two cases of pile head restraint, pin and fix were considered in the analysis, and they concluded that when the piles were fixed rather than pin, the capacity of hybrid foundation was significantly higher for various length of pile. Then Shehunjan and others in 2017 carried out numerical stimulation in order to provide better understanding of impact of multidirectional loading on the capacity and displacement of hybrid foundation system by creating the 3D failure envelope. And they concluded that the shallow foundation shows gradually growing resistance when the load was applied, and while deep foundation showed substantially early lateral and vertical loading resistance. Then next one is the problem definition. So the analysis in the present study consists of modeling conventional mud-mat foundation and hybrid mud-mat foundation embedded in layered soil with a different length, number of perforations and water level of 16 meters above the seabed level to determine the ultimate lateral load capacity. The sections of conventional mud-mat and hybrid mud-mat foundation used for the analysis is as shown in figure. The first figure shows, next slide. This figure shows the cross section of conventional mud-mat foundation considered for the analysis. Here, this is the mud-mat foundation which is provided at the seabed. Over that, there is a sea water level, and the first layer consists of 7.5 meter, and the second layer consists of 42.5 meter, and the perforations are provided within it. And the next one is next slide. This figure shows the cross-section of hybrid mud-mat foundation considered for the analysis. Here, the only difference is that the piles were provided. Then next. Then this table shows the details of parameters selected for conventional mud mat foundation. The constant parameter is breadth of mud mat, external skirt along length and width, thickness of skirt, diameter of perforations in mud mat, spacing of perforation, and the variable parameters that is length of mud mat 10 meter, 12 meter, 14 meter, and 16 meter, number of perforations 6, 12, and 18, and skirt depth. Then next slide. Then this table shows the details of parameters selected for hybrid mud mat foundation. The constant parameter is breadth of mud mat, external skirt along length and breadth, thickness of skirt, then number of pile inset from mud mat to corner pile center, then diameter of pile, diameter of perforations in mud mat, spacing of perforation, and the variable parameters that is length of mud mat, length of pile, skirt depth, and number of perforations. Then next slide. This table shows parameters selected for soil bed. The first layer consists of soft clay, which is having thickness 7.5 meter, and the next layer is dense sand having a thickness 42.5 meter, and the depth of the water above the seabed level, that is 16 meter. The mud mat and pile parameters selected for mud mat and pile were Young's model is of steel, having Young's modulus, unit weight, and Poisson's ratio. Then next slide. Next slide. Then the properties assigned to the soil layer for the analysis, that is unit weight, saturated unit weight, Young's modulus, Poisson's ratio, angle of internal friction, and cohesion. The properties were assigned for soft clay and the sand, which is taken from the literature. Then methodology. Next slide, please. The whole analysis is carried out by the software GTS NX3D. For the analysis, 3D numerical model of conventional and hybrid mud mat foundation with a soil block is modeled. Geometry of foundation is developed according to the required dimension. Material properties were assigned, as we can see previously. Then attribute for the foundation and soil are specified. Separate meshing is provided for the foundation and soil model. Then boundary condition is defined and lateral load is applied, and then model generated is then analyzed. After the analysis is complete properly, MIDA GTS NX3D organize and provide post data return for design process. Then next slide. This is the figure which shows the geometry of hybrid mud mat foundation developing MIDA GTS NX3D. This is as we can see at 16 meter the water is provided, and this is the soil block, and within that the foundation is embedded. Then next slide. Next slide. Then the result and discussion. The analysis were carried out for each case, and for each case, lateral load versus displacement curve were plotted, and the ultimate lateral load capacity of conventional mud mat and hybrid mud mat foundation were determined, corresponding to lateral displacement equal to 10% of width of mud mat, that is 0.5 meter. And the result of analysis were presented in table. Next slide. Next. Here the table shows the ultimate lateral load capacity of conventional mud mat foundation. The number of perforation is 6, 12, and 18. And for each case, the length of the mud mat is 10 meter, 12 meter, 14 meter, and 16 meter. And for each skirt depth, the capacity were find out. Then next slide. Next slide. Then this table shows the ultimate lateral load capacity of hybrid mud mat foundation. Similar analysis is carried out for number of perforations 6, 12, and 18. For length 10 meter, 12 meter, 14 meter, and 16 meter, and the length of pile here is 12 meter. And next slide. Next slide. Next slide. Then discussion of result. Here this figure shows the variation of lateral capacity with skirt depth from hybrid foundation. From this figure, it was found that as the skirt depth increases, the capacity of the foundation is increases, but as the number of perforation increases, the capacity is reduced. Then next slide. Next slide. Previous slide. Previous slide. This figure shows the percentage increase in ultimate lateral load capacity of hybrid mud mat foundation for the number of perforation 10. Here the bar chart are presented, and the percentage increase in ultimate lateral load capacity where find out. And next slide. This percentage increase in this figure shows the percentage increase in ultimate lateral load capacity for hybrid foundation having number of perforation 18. Then next. Then conclusions. Ultimate lateral load capacity. From the analysis, it was found that the ultimate lateral load capacity of hybrid mud-mat foundation is substantially higher than that of conventional mud-mat foundation, which is 154.54%. The percentage increase in ultimate lateral load capacity of hybrid mud-mat foundation is maximum in case of length of 10 meter, that is 154.54%. The maximum lateral load capacity of conventional mud-mat foundation and hybrid mud-mat foundation increases with increase in case of mud-mat of length 16 meter and skirt depth of 1.5 meter, which is 8,800 kilonewton and 10,600 kilonewton respectively. Then next slide, previous slide, next slide. After conclusion, next slide. The lateral load capacity of conventional mud-mat foundation decreases from 3,000 kilonewton to 1,600 kilonewton with increase in number of perforations from 6 to 18 in case of mud-mat of length 10 meter and skirt depth of 0.5 meter. And the lateral load capacity of hybrid mud-mat foundation decreases from 5,600 to 70 to 3,820 kilonewton with increase in number of perforations from 6 to 18 for length of mud-mat 10 meter and skirt depth of 0.5 meter. Then the references. Next slide. Then these are the references. Thank you. Then next slide. Next slide. Then thank you so much for Amity University for giving me this opportunity. And I would also like to thank my co-authors who guiding me and helping me during this project. Thank you so much.
Yeah, Avanti, good work you have done.
Thank you, sir.
Now tell me a few things like this, how you are modeling this hybrid foundation, like how you have considered the pile and the mud mat.
Yes, sir. The size of the mud mat are taken from the literature, and in GTS Annex MEDAS, there are various functions, that is rectangle, square, rectangle, circle, through which the geometry is created, and then exclude function is used, and the whole geometry is then whole geometry is applied with Boolean operations, and the properties were assigned, and the analysis is carried out.
So between the mud mat and the pile, is there any interface elements, or how you are joining them?
No, sir. The piles are embedded within the mud mat.
Okay.
So it acts as a single unit.
So it's a single unit.
Yes, sir.
And then coming to the pile fixity, so what boundary conditions you are selecting?
5 boundary conditions for soil model, where 5 length means length of 5 L by 5 by 50 means length of mud mat, 5 times length of mud mat, and 5 times length of width of mud mat, and 50 meter.
Okay, and what kind of loadings you have considered?
Yes, sir. Here I have only considered the lateral loading. The vertical loading will be constant, but in general there may be a torsional loading due to thermal and thermal expansion and contraction of pipeline and jumpers which are connected to that foundation. So this may be a future scope for the study.
Because there will be a combination of loadings.
Yes,
until
sir. Yes,
until which you have to work that what is the actual increase in the load capacities.
Yes, sir. Yes, sir.
And also this soil case, you have taken specific case study from some paper?
Yes, sir. I have considered the soil properties from Gulf of Khambar, Gujarat in Maharashtra.
Okay. Okay. Thank you.
Thank you so much, sir.
Can we have paper ID 189 next?
Yes, sir.
Okay, you can begin with the presentation.
Okay. Good morning for everybody. My title is study on the effect of bottom ash on the California bearing ratio of clay soil. Name of author Muhammad Faisal Numan and Mahbub Anwar Khan and Kauthar Ali. Name of presenter of Muhammad Faisal Numan, Aligarh Muslim University. Presentation content is introduction and literature review and problem formulation and methodology and result and discussion and conclusion and reference. Introduction is stabilization of soil means the improvement of the geotechnical properties of soil. There is many types of the stabilization of soil, like the mechanical and chemical and physical and hydraulic stabilization. And there is also many types of material you can use it to stabilization of soil, like the cement and lime and fiber, dirt and other waste material. One of the most challenging for the civil engineering is the construction of a highway network to meet the needs of the expansion wave and to help in the economic recession. With the road project in the areas under development need a high bearing capacity compared to the road network in the urban area. A large proportion of this expansion is based on the unstable clay soil, which has a weak CBR value. When built of pavement on the top of the subgrade clay soil, when exposed to vehicle load the clays will file as the foundation for pavement. The previous research focused on the enhancing the CBR rate of clay soil was by natural and synthetic fibers such as the pure chinchal and husic fiber and geograde and nylon fiber and polyester fiber. The purpose of this study was to investigate the impact of bottom ash when used as a chemical addition has on the rate at which water is disintegrated from clay soil. This is the methodology that is sample was prepared by adding the different presenting of bottom ash to blend clay soil such as the 5 and 10 and 15 and 20 and 25 and 30 and 35 and 40, 45 and 50%. Additional to the two samples as standard, one blend clay soil and one blend bottom ash. Result and discussion. Step 1 is the effect of period soaking on the CBR value as of mixture of clay bottom ash. The high when I have applied the two simple standard blend soil and blend bottom ash and also non-socket and other simple socket for 48 hours and another one for 96 hours. And we have compared the result as shown in the figure. The higher reduction in the the decreased in on the CBR value was registered directly after soaking sample for 48 hours. The result, as shown in the figure, the blend soil CBR without socket, it was around 8.63. And after 48 hours, it was it decreased up to the 5.73, and after 96 hours, it decreased around the 5.43. Effect of bottom ash on the CBR value of clay soil, the maximum. As shown in the figure, the maximum improvement in the CBR value is observed as shown in the graph. When added the 25 bottom ash, we have get the optimum content of bottom ash. Conclusion: the optimum duration for soaking CBR value sample is of 48 hours, with decreased rate of CBR by 91% of rate and CBR for plain clay soil sample without soaking, while decreased rate of the CBR by 92% of rate of CBR for plain bottom ash simple without soaking. The CBR value of clay soil increased with added bottom ash up to 25%. The curve reaches its maximum value point. This it start to decrease at lower values. The the bosonic behavior of the bosonic activity of the bottom ash may be the reason for the increase in CBR. This is correlated with its amount. Thank you.
Yeah, Faisal.
Yes, sir.
So tell me one thing. What about the bottom ash? How you are mixing the bottom ash in the soil?
Yes, sir. We have mixed the bottom ash with the clay soil as manual by hand. We have and we have added the optimum moisture content OMC for 8% after do the the compaction test.
So you have worked out OMC for every composition?
Yeah, for every composition.
So you are able to achieve the required density as per the OMC?
No, I didn't check the required density. I get it the OMC for each composition by the Proctor test. Then we have mixed the bottom ash with the clay soil.
So as per your finding that CBR increases with bottom ash up to 25%.
Yeah, this is the optimum content.
So what was the increase in the numbers? What was the CBR value before and after?
At 25, it was around 9.12. And before, for the plain soil, it was after for plain soil, it was before at the bottom ash, it was around 5.73, and this for the clay soil without bottom ash.
So any reason why after 25% it is decreasing?
Yeah, it decreased as shown in the figure. It will be around 4.89.
So after 25%, why it is decreasing? If I mix 30% of ash or 40%,
yeah.
So why CBR is going down?
I think with we add the big quantity of bottom ash to the clay soil, the behavior of a clay soil is changed. It will be like another type of soil, like the salt. They change the composition of the clay soil, the natural composition.
So when you are making that sample with more than 25%, is there any problem in making the sample? Because 30%.
Yes, I get some problem. The soil, it will be cohesion with the blanket during the filtration.
So there will not be a uniform mixing with the soil if you are increasing the bottom ash.
Yeah.
That could be the reasons why you are not getting any increase.
No, after that, up to 15, we didn't get any increase. After 20, between the 25 and 15, we didn't get any increase. But for the plain bottom ash, the CBR value, it increase. It's more than plain soil and 25% with the clay ash.
Okay, thank you.
Thank you.
Okay, we can take up next presentation.
Deepika, can you present next?
Yes, sir. Hello.
Yeah, sure.
Sir, am I audible?
Yes, you are audible.
Please unshare this presentation, Faisal. Yeah.
So my screen is visible. Hello.
Yeah, Deepika, start.
Yes, it's visible.
Okay, sir. Okay. Good afternoon, one and all. I am Deepika Praveen Mittange, here to present my work on development of design chart for rectangular barrette. Currently, I am pursuing my MTech from Government College of Engineering, Amravati. Co-author for this work are Professor S.W. Thakre sir and Dr. A.I. Dhatrak sir. Let's start with the contents. So these are the contents of today's presentation. First, we will see introduction, followed by brief review of literature. Then we will see problem formulation, then methodology involved in this work. After that, we will see result and disclosure. And lastly, we will see conclusion, followed by references. Let's start with the introduction part. A cast-in place reinforced concrete pile that can withstand the load and high movement is called as a barrette. Typically, piles are rectangular piles. Because of their excellent carrying capacity for both lateral vertical load, foundation for high-rise buildings, barrette are frequently used. In case of circular cast-in situ pile, the accomplishment of necessary socket length uh, using the rotary pile drilling rigs is widely recognized to be one of the main issue, and also due to the limited capacity, cast in situ individual circular piles become impracticable and expensive when significant superstructure loads are carried to the deeper soil layer. In such a circumstances, barrettes provide a deep foundation solution alternative to the huge diameter cast in situ piles. The rectangular design of barrettes prevent them from withstanding equal loads from all the directions. Now let's see the literature which has studied for this work. First one is by Zhang and other. In 2003, they studied the reaction of laterally loaded large section barrette to stimulate the response of the two test barrette and analyze the impact of loading direction on the lateral response of barrettes. Based on their research, they concluded that the direction of corresponding horizontal displacement is different from the loading direction if the barrette is not loaded along the major or minor axis of the cross section. Then next literature is by Karthikeyan in 2000 and other. In 2007, they performed the finite element analysis in 3 dimensions that demonstrate the major impact of vertical load on pile's lateral response. According to the result, the lateral response of pile is greatly affected by the vertical load in sandy soil and only little by vertical load in clay soils. Now, next literature is by Vakil and others. In 2013, they investigated the reaction of barrette on rectangular cross section when loaded laterally. The effect of sand relative density, pile aspect ratio, loading direction, and load eccentricity were examined by using 28 model experiment for a laterally loaded barrette. According to their study, a barrette loaded in the direction of the major axis will have the higher lateral resistance than barrette loaded in the direction of minor axis. Then last literature by Chawda and other. In 2017, they carried out the finite element employing the plane strain idealization. They determined the single barrette maximum capacity. The ultimate capacity is influenced by the soil strain parameter, unit weight, surcharge at the ground level, interface strength, and barrette geometry. Now let's see how a problem was formulated. The analysis in the present study consisted of the modeling of rectangular barrette and group of circular pile in different type of soil with inflation parameter, cross-section areas of barrette, the diameter of circular pile, number of pile in group, and type of soils. In this figure, we can see the cross-section area of rectangular barrette, which is considered for the numerical analysis. Here is the front view in which B is the breadth of the barrette, which is the longer dimension. L is the total length of barrette, and small t is the thickness of pile gap, which is 1.5 meter. And on other side, we can see the side view of the barrette, where W is the width of barrette, which is the smaller dimension. Now let's see the methodology involved in this work. The detailed 3D model of a rectangular barrette with a soil block and group of circular pile was modeled in the FEM software program, which is Midas GTS NX 3D. The analysis were carried out on various sizes of rectangular barrette in different type of soil, namely clay, sandy, and C5 soil for lateral loading. The various parameters considered for study and their values for analysis are shown in table 1. Here for analysis, the length of pile was kept constant, which is equals to 30 meter in all cases. Here the varying parameter for rectangular barrettes are breadth and width, while for circular pile, diameter and number of pile group are varying. Now in table 2, we can see the properties of soil used in numerical analysis. Here, unit weight, Young's modulus, Poisson's ratio, angle of internal friction, and cohesion for clay, sandy, and C5 soil is given. Now in table 3, we can see the properties of concrete used in this numerical analysis. We consider the M25 grade of concrete, and unit weight, Young's modulus, and Poisson's ratio for concrete is given in this table. Now, analysis were carried out for every individual case by applying the lateral load in increment. The ultimate lateral capacities were considered as per criteria laid down by IS 2911-1985 Part 4. The ultimate lateral capacities were considered corresponding to 12 mm of deflection. In this figure, we can see the window in Midas GTS NX 3D after the application of lateral displacement. Here 12 mm of prescribed displacement was assigned and load intensity then obtained for the deflection. Now let's come to result and discussion. The parameters considered for analysis were width and breadth of the barrette. Type of soil are clay soil, sandy soil, and C5 soil for lateral loading. The load displacement curve for each case were generated, and the ultimate load were obtained for the different cross section of the barrette pile. The design charts were then developed by plotting the lateral capacity versus the breadth of the barrette. Such a charts were developed for various width of the barrette, and the analysis were carried out to determine the ultimate lateral capacity of group of circular piles of diameter 0.8 meter and 1 meter in clay soil, sandy soil, and C5 soil. Now the replacement of group of circular pile in clay, sandy, and C5 soil consisting of 2, 4, and 6 pile with a single barrette were considered using these design charts for the barrette of weight 0.8 meter and 1 meter. The capacities of group of circular pile were then compared with those of the single rectangular barrette with the help of design chart developed, and then the percentage reduction in cross-section area due to the replacement of circular pile with single rectangular barrette was determined. And lastly, the optimum sizes of the single rectangular barrette to replace the group of circular pile were then decided. In this figure, we can see the design chart for replacement of group of 2 circular pile by single rectangular barrette. Here the blue curve indicates the lateral capacity of barrettes whose width is constant, which is 0.8 meter, and red curve indicates the lateral capacity of barrette having the constant width 1 meter. Now on this chart, the lateral capacity of group of circular pile were plotted on the curve such that it gives the minimum corresponding dimension for minimum corresponding dimension of single rectangular barrette. Now table 4 shows the percentage reduction in cross-section area due to replacement of group of 2, 4, and 6 circular pile with single barrette in clay. If we consider the first case, here the group of 2 circular pile of diameter 0.8 meter, the lateral capacity was found to be 2007 kilonewton, and it has area of 1 meter square. Now from the design chart, the dimension obtained for single rectangular barrette for the same capacity are 0.8 by 1.2 meter, whose area is found to be 0.96 meter square. So from this calculation, it is observed that percentage reduction in cross-section area is 4%. And we may replace the group of circular piles with single rectangular barrette. Similarly, other calculations are made, and it was observed that if we replace the group of circular pile with single rectangular barrette, there is significant reduction in the cross-section area due to replacement of group of 2, 4, and 6 circular pile with single barrette in sand. Then in table 6, we can see the percentage reduction area due to the replacement of group of 2, 4, and 6 circular pile with single barrette in C5 soil. Now let's come to the conclusion. Based on the results of the analysis, the following broad conclusions are drawn. First, a group of circular pile may be replaced by a single rectangular barrette having the equal lateral capacity, but with the reducing cross-section area, thus resulting in saving in cost. A second one is, in the case of clay soil, the percentage reduction in cross-section area due to replacement with a single barrette is highest, which is 20.38% in the case of 4 piles with diameter of 1 meter. Then third conclusion is, in case of sandy soil, the percentage reduction in cross-section area due to replacement with the single barrette is highest, which is 42.67% in the case of 4 pile with the diameter of 1 meter. And in the case of C5 soil, the percentage reduction in cross-section area due to replacement with the single barrette is highest, which is 7.64% in the case of 4 pile with the diameter of 1 meter. Now these are the references. Lastly, I like to thank my co-authors, Professor S.W. Thakre sir and Dr. A.I. Dhatrak sir, and also like to express my thanks to MIT University for giving me such an amazing opportunity. Thank you.
Yeah, Deepika, good work you have done.
Thank you, sir.
Now tell me some few clarifications.
Okay.
Now, as per your study, you have considered 3 types of soil, na? Phi
Yes,
soil,
sir.
C soil, and C5 soil.
Yes, sir.
And the minimum reduction you have achieved for C5?
Yes, sir. Minimum reduction achieved for C5 and maximum in case of sandy soil.
So now most of the places you will have like C5 type of soil only?
No, sir.
Yeah.
I have done for 3 type of soil.
So this you have taken some case study or you have assumed it?
Sir, what properties?
Yeah.
Sir, I have taken properties of soils from references. For clay and sandy soil, I have referred S. Karthikeyan. And for C5 soil, I have referred the GIT report from Nagpur Metro.
Okay. So now coming to the part of replacing the circular pile with a rectangular barrette.
Yes, sir.
So whether earlier some actual practical studies are there where this replacement has been done?
No, sir. No, sir.
So most of the work are theoretical studies or numerical analysis work.
Yes, sir. Actually, sir, replacement. I have studied many literatures, so there is no work done on the replacement of a group of circular pile with single barrette.
Because maybe because the thing you are achieving in case of a C5 soil, the reduction is not much, only 7-8%.
Yes, sir.
So only in case of a pure sandy soil or something, the reduction will be sufficient.
Maximum, yes, sir. Right.
But most of the sites you will have some C5 kind of soil.
Yes,
So
sir,
in that case, the advantage of replacement will not be practically that important.
Okay, sir.
So that's why I wanted to know you have some practical seen somewhere or some paper where they have actually done this.
No, sir, there are no practical applications. So applicable papers are there.
And also, what about the drilling? How you feel between a circular pile and rectangular pile? Which one you compare it to easier one while installing it?
Sir, installing process are same for as that of for circular pile.
Okay, and the embedment depth requirement is also same for both?
Yes, sir.
ठीक है दीपिका, okay, thank you.
Okay, thank you, sir.
Okay, Rajni, you can present next.
Hello.
Yes, you are audible.
Hello.
Yes, your screen is visible.
Okay. I'm currently pursuing my post-graduation in geotechnical engineering from the Government College of Engineering, Amravati. I'm here to present my research topic under the title of the co-authors for this research work are Dr. A.I. Datrak and Professor S.W. Thakre sir. Here the term deformable inclusions, which represent a geoform material, when they are subjected to dynamic loading by using the shake table test with the use of deformable inclusions means geoform material. Literature review, problem formulation, experimental methodology, result and discussion, conclusion and references. So starting with the introduction, when they have to register the material behind the wall. But in case of the earthquake prone areas, retaining walls should be built to withstand both static as well as dynamic increments in material. Here shows the retaining wall construction with EPS geoform backfill. Here EPS is the expanded polystyrene material. When these EPS geoform blocks are placed behind the retaining wall, in addition to the granular material, into the retaining wall. There are various types of researches have conducted which suggest that the geoform inclusions are effective in reducing the dynamic earth pressure of wall as well as the geoform compressible inclusion can be determined by two methods. First one is numerical analysis using finite element methods such as MIDAS or Plaxis study, and second one is shake table. I have the second method. For experimental investigation, various laboratory shake table tests were conducted on retaining wall model, which is made up of the cement mortar. Review, Zekos and all in 2012 have conducted the numerical analysis using Plaxis to investigate the effect of EPS geoform in reduction of seismic earth pressure and dynamic earth pressure and horizontal displacement of wall was reduced up to 20% and 50% respectively. Bathurst and all performed the experimental against rigid soil retaining wall, and they have found out that there is a reduction in dynamic earth pressure up to the 15 to 40%. Problem on retaining wall, which is made up of the cement mortar, when sand and geofoam was used as a composite backfill material instead of the conventional backfill material. This is a rigid solid. This is a rigid solids box, and this is a shaking platform. This is a dynamic actuator. And this is a control unit. This control unit is used for the amplitude of 10 mm. This shaking table platform is moved forward direction and backward direction at the distance of 10 mm. There are various accelerometer which measure the acceleration, and pressure transducer measure the lateral earth pressure coming on the wall. With the help of these various sensors, we can predict the behavior of
I have made a study. I have conducted Series 1 model retaining wall without any inclusion. Series B model retaining wall with provision of geofoam material. The experiment set of this study is identical, only the difference of provision of geofoam material. Two prototype walls were selected with height of 6 meter and 5.4 meter. According to the test availability criteria, according to this scale ratio, the height of model wall is 400 mm and 360 mm. Inclusion material which is used as a EPS 18. Here EPS 18 50 mm. Figure 3 shows the retaining wall model which is made up of cement mortar, and figure 4 shows the EPS geofoam material used for the sand which is called as a Kanhan sand passing through the 4.75 mm sieve which is used as a dry cohesionless backfill in addition to the geofoam material. Table 1 shows the properties. This soil can be classified as a poorly graded sand, specific gravity, bulk unit weight, similarly angle of friction, coefficient of uniformity, coefficient of curvature as given. Experimental investigation. There are three parameters were selected: a wall height 400 mm and 360 mm. Two wall heights are selected to determine the height of wall. Frequency selected. Amplitude were selected: 5 mm, 7.5 mm, and 10 mm. A thickness of foundation weight is determined. Foundation weight by sand rainfall method. The density of sand is constant throughout the whole experiment. The figure 5 shows the schematic view of I have shown earlier. The first step of the experiment is to prepare the compacted sand bed up to the height of 20 centimeter. After that, are used such as accelerometer, pressure transfer, and LVDT. Two accelerometer was attached, one at the base of retaining wall and one at the top of the backfill material. Two mid height of retaining wall and second at the base of retaining wall. At the top of the retaining wall, D represent the LVDT, means linear variable distance transfer, are attached to measure in front side of the wall. The base of wall is embedded up to the thickness of 50 mm, and at the back side of the wall, the to the total height of retaining wall. This is a final shakable setup of retaining wall without geofoam material and with the provision of geofoam material. The experiment is geofoam material behind the retaining wall. Result and discussion. Result of dynamic earth pressure on retaining wall. As we can see at base, which is P2, and the dynamic earth pressure on retaining wall. Table 3 shows the dynamic earth pressure on retaining wall for amplitude and through hertz frequency. We can see that the value of P1, which is at mid height, is 1.29, and when we use the geofoam, it is reduced to 0.94. There is a reduction in dynamic earth pressure when we use the geofoam material. The same trends followed for the P2 force. Table 4 shows the dynamic earth pressure on retaining wall for 360 mm wall. And to use the geofoam material. From this value, I have calculated the percentage reduction in dynamic earth pressure on retaining wall, and the percentage reduction is compared on the base of percentage reduction for P1 and P2 are greater as compared to the wall height of 400 mm, and the greatest greatest percentage of reduction are found out for the figure shows the variation of percentage reduction in dynamic earth pressure at mid height which is P1, bottom which is P2 for 2 and 7.5 and 10 mm. From the figure we can see that the percentage reduction R goes on increasing as the frequency and increasing. But we find out the maximum at a frequency of 3 Hz and 10 mm amplitude. The percentage variation for 360 mm model height follows as per the 400 mm wall model height. Only the difference is that there is a percentage reduction are more in case of 360 mm model height. Result of horizontal displacement of retaining wall model and the percentage reduction on horizontal displacement for model height h is equal to 400 mm. For 5 mm amplitude and 2 Hz frequency, when which means is not provided, the horizontal displacement of wall is 0.8 centimeter, and when we provide a geoform, it reduces up to 0.6 meter, 0.5 centimeter, and reduction in this case are 7.5. Horizontal model and the percentage of reduction in horizontal displacement for h is equal to 360 mm model height as shown in table 1. Horizontal displacement of wall, but for 360 mm wall model there is a greater percentage of reduction as compared to the 400 mm wall model. This figure shows the variation of percentage reduction for 400 mm and 360 mm for frequencies of 2 Hz and 3 Hz with respect to the selected amplitude, which is 5, 7.5 and 10. You can see that the percentage reduction goes on decreasing as the amplitude and frequency increasing. Means this case is exactly opposite as compared to the dynamic pressure range, but the similarity it gives a better result for smaller height. And from this result and discussion, we have concluded that there is a reduction in dynamic earth pressure.
Rajni, please finish your presentation in next 2 minutes.
Okay, sir. Reduction in dynamic earth pressure is higher in case of wall of 360 mm, which is 38.6 as compared to that wall of 400 mm height, 35.8 meter at mid height of wall. And the reduction in dynamic earth pressure is higher in case of the wall of smaller height, 35.1% as compared to the wall of dynamic earth pressure. Both cases at mid height and at base of the wall use the base result for 360 mm wall model. Wall model. Geoform efficiency towards reduction of dynamic earth pressure increases with increase in frequency and amplitude of vibration, and which is exactly opposite happen in case of magnitude of vibration increases. And there is a by using the geoform material as a deformable inclusion, we can see the significant difference between the dynamic behavior of retaining wall I would like to thank to all of you for your patience listening, and I also want to thank and Dr. Datrak sir. And lastly, I want to thank Amity University for providing me this platform to present my work. Thank you.
Yeah, Rajni. Okay, good. So you have done some model studies, as I understand, right?
Yes, sir.
So now tell me one thing, out of your conclusion, you are saying that the behavior is different when you are using this geoform. So any reasons why this behavior is changing? Anything from the literature or from your own experiment you can suggest that when we add a geoform, what difference it comes?
Sir, when we provide a geoform behind a retaining wall, it lessens the magnitude of pressure coming from the wall. Hence, the magnitude, the pressure acting on wall is become lessened, and due to which the horizontal displacement of wall is also less, and the pressure acting on wall is less, whether it is static pressure or dynamic pressure.
Your voice, I am getting out of lot of cracks are there within the voice. I'm not able to hear properly. Anyhow, what I could get is you are saying it will reduce the pressures when we add this geoforms. Right?
Sir, I'm not clearly.
Hello.
Hello. Sir, can you repeat the question once?
When you are adding this geoform, so how does the behavior is changing when you are applying the forces?
Sir, there is a less magnitude of force act on the wall when we use the geoform material behind the wall.
Okay.
And the displacement of wall is also less.
So this you have considered under the model using the LVDTs, right? So have you done any numerical modeling also for it?
What, sir? Can you repeat once?
In addition to the model that you have studied, any numerical studies were also carried out? Okay, I think I'm not able to hear your voice properly. Some disturbance is there.
I think we should move next
Yeah,
part.
okay, Nick, thank you. Okay, next.
Afrin, I am presenting your PPT.
Yes, sir. Am I audible?
Yeah, go ahead.
Good afternoon, everyone. I'm Afrin Khan, and I'm going to present my work on the topic numerical analysis of H-shaped Barrett file subjected to vertical and lateral loading. My co-authors are S.W. Thakre sir and Dr. A.I. Thatrak sir. I am currently pursuing M.Tech from Government College of Engineering, Amravati. Next slide, please. These are the contents. Firstly, I will introduce, followed by the literature review, then problem formulation and the methodology adopted for the analysis, results and discussion, followed by conclusions and references. Next slide. Starting with the introduction, we know that the Barretts are cast in place reinforced concrete piles. It refers to a concrete replacement pile, which is formed in a short and deep trench excavated under bentonite or polymer slurry by diaphragm walling equipment. Barretts have much of the same purpose and design as that of the conventional piles. They offer an alternative to drilled shafts or large diameter pouring and cast in place piles. Next slide, please. This is because a Barrett has a higher specific surface than a circular pile for resisting large vertical loads by shaft resistance. A more compact, cost-effective, and reliable foundation system is created by a fact that a single Barrett can replace a number of standard circular piles in many situations. One of the key benefits of the Barrett pile is that they have significantly higher bearing capacity as compared to the circular piles, which is essential for meeting the increasing demand for loading from tall buildings. So the Barretts have additional benefits of cost saving. Additionally, the time needed to trench Barrett piles is shorter than the time needed to drill circular piles. Next slide. Literature review. C. Submani Wong and others in the year 2009 presented the performance of T-shaped Barrett pile against lateral force and compared the measured and predicted pile movement under lateral loading. Next author A.Z.E.I. Vakil in the year 2012 presented the results of study of behavior of laterally loaded small-scale Barretts in sand. Next, Jitesh T. Chawda and others in the year 2017 evaluated the ultimate capacity of a single Barrett using finite element analysis. The effect of parameters like unit weight of soil, strength parameters, surcharge, deformation parameters, interface strength between the Barrett and soil, and geometry of the Barrett was evaluated. Next slide. Next slide, please. H.G. Polis and others in the year 2019 examined the use of basic analysis tools, which was based on common circular cross-section piles. The behavior of the equivalent piles was compared to the finite element results for the Barretts. These results were compared with those obtained from three-dimensional finite element analysis of the rectangular Barretts. Sohail Qureshi and others in the year 2020 reported the results of experiment on Barrett foundations of various shapes, including rectangular, T-shape, cruciform, and H-shape, resting in the sand and being loaded vertically. According to their results, Barretts have significantly higher ultimate vertical capacities than circular piles with the same cross-sectional area. Next slide, please. Problem formulation. The analysis in the present study consisted of modeling of a single edge-shaped Barrett pile and a circular pile of same cross-section area in order to determine the ultimate vertical and lateral load carrying capacities. The type of loading included vertical as well as lateral loading, and the analysis were carried out for varying width B and breadth W of edge-shaped Barrett piles in different types of soils, namely clayey, sandy, and C5 type of soil. Next slide, please. Next, table 1 shows the shapes of piles and the dimensions selected for the analysis. The diameter D of the circular pile is selected in such a way that the area formed of H pile is the same, so that the cross-sectional area of D of the circular pile as well as H-shaped pile is same. Next slide. Next slide, please. Methodology. The geometry of H-shaped Barrett pile along with its pile cap and soil block was modeled in Midas GTS NX 3D software. For creating H-shaped Barrett pile, 3 rectangles of required dimensions were used and surface Boolean operation were used for joining the 3 rectangular geometries. Also, extrude function was later used to achieve the required depth of the H-shaped Barrett pile. The figure 1 shows the geometry of H-shaped Barrett pile, which was developed in Midas GTS NX 3D software. Next slide, please. Table 2 shows the material and soil properties assigned for analysis. As the pile and pile cap are completely made up of concrete material, hence the material model selected for the analysis was elastic model, and the model for clay, sand, and C5 type of soil, that is for soil block, the model selected was Moore Coulomb. And the other properties such as elastic modulus, Poisson's ratio, unit weight, saturated unit weight, cohesion, and friction angle are taken from the references. Next slide. In the next step, separate meshing was provided for pile, pile cap, soil block, and interface elements were created. Then auto boundary condition was defined, and a uniformly distribution load, which was of pressure type, was applied on the pile cap, and self-weight of the geometry was provided. For the analysis, nonlinear static solution was selected. The ultimate vertical and lateral load capacities were considered as per the criteria laid down by IS 2911-1985 Part 4. A typical H-shaped Barrett pile along with its pile cap and soil block model for the analysis in Midas GTS NX 3D is shown in the next figure. Next slide. This figure shows the typical H-shaped Barrett pile along with its pile cap and soil block model for the analysis in Midas GTS NX 3D software. Next slide, please. Results and discussion. As I already mentioned, the parameters selected were cross-sectional area of Barretts and types of soil, that was clayey, sandy, and C5, and loading included vertical as well as lateral loading. So the ultimate vertical and lateral capacities for H-shaped Barrett piles of various widths, that is B, and breadths, that is W, and circular piles of same cross-sectional area in clayey, sandy, and C5 type of soil were determined. Next slide, please. So this table shows the ultimate vertical and lateral capacities of circular and H-shaped Barrett piles in clay soil. From the table, we can observe that the cross-sectional area of both the piles, that is H-shaped Barrett as well as circular Barrett, is same, but the vertical capacity as well as lateral capacity is higher as compared to that of circular pile. So these H-shaped Barretts prove to be more economical and provide you the more capacities. Next slide, please. The same pattern of higher vertical and lateral capacity is observed in for all the dimensions of H-shaped pipe. Next slide, please. Similarly, ultimate vertical and lateral capacities of circular and H-shaped barrettes in sandy and C5 type of soil were determined. Next slide. Then the percentage increase in vertical and lateral capacities of H-shaped barrette pile as compared to the circular pile in clayey, sandy and C5 soil of C5 type of soil are shown in this table. Next slide, please. Next slide. Next slide, please. Next slide. So these variation of percentage increase in vertical and lateral capacities of edge-shaped barrette pile as compared to the circular pile with respect to widths of barrette in clayey soil is shown in figure 3 and 4 respectively. Next figure. Next slide. Here the figure 3 shows the variation of percentage increase in vertical capacities and figure 4 shows the variation of percentage increase in lateral capacities. From the graphs, it can be observed that the percentage increase in vertical capacity shows a decreasing trend with the increase in breadth of barrettes, and in the lateral and for the percentage increase in lateral capacity, it shows an increasing trend. Next slide, please. Similarly, the variation of percentage increase in vertical and lateral capacities of edge-shaped barrette pile as compared to the circular pile of similar cross sections with respect to widths of barrette in sandy and C5 type of soil were plotted, and similar trends were observed in sandy soil. However, in case of C5 type of soil, different trends are observed, which are shown in figure 5 and 6. Next slide, please. The figure 5 shows the variation of percentage increase in vertical capacities of edge-shaped barrette piles in C5 soil. Here we can observe that there is an increasing trend in the percentage increase in vertical capacity with the increase of breadth of barrettes, that is W, and for the percentage increase in lateral capacity, similar trend, that is increasing trend, is observed. Next slide. Coming to the conclusions, the ultimate vertical and lateral load capacities of edge-shaped barrette pile are higher as compared to the circular pile of same cross-sectional area. The percentage increase in vertical capacity of edge-shaped barrette shows a decreasing trend with increase in the breadth of barrettes in clayey, sandy soil, whereas it shows increasing trend in case of C5 soil. The percentage increase in lateral capacity of edge-shaped barrette shows an increasing trend with increase in breadth of barrettes in clay, sandy, and C5 soil. This was explained by the graphs. And the percentage increase in case of clay soil for vertical capacity is in the range of 9 to 25%, and for lateral capacity, the range is 16 to 65%. Next slide, please. Then in case of sandy soil, the percentage increase in vertical capacity of edge-shaped barrette pile as compared to those of circular pile of same cross-sectional area is in the range of 20 to 34%. And for the lateral capacity in sandy soil, the range is 16 to 52%. Then in case of C5 soil, the percentage increase in vertical capacity of edge-shaped barrette pile as compared to those of circular pile of same cross-sectional area is in the range of 26 to 39%. And for lateral capacity, the range is 14 to 50%. Next slide, please. These are the references which I have used for the study. Next slide. Next slide. Thank you for all the patient listeners, and I also express my special thanks to the Abiti University for giving me an opportunity to present my paper. Thank you.
Yeah, Afreen, thanks. Had a good presentation.
Thank you, sir.
Just few quick questions I wanted to have. First, can you tell me something about the structural action of an H pile as compared to other piles? Is there any difference in the structural action of a H pile? How does? Yeah, go ahead.
Actually, sir, the structural of H-shaped barrette pile as well as circular pile is same, but it it shows more resistance to load, and that's why as I have shown in the table, the capacities of H-shaped barrette pile were higher as compared to the circular pile, having same cross-sectional areas.
If I take a rectangular barrette and an H-type barrette, still H will be higher?
Yes, sir.
So what kind of different barrettes are used? Normally rectangular, H?
Sir, actually we have 4 to 5 types of barrettes. First is a rectangular barrette, and then H-shaped barrette, L-shaped barrette, I-shaped barrette, then plus, which is called as cruciform barrette. And so these are the types of shapes of barrette used.
So out of these, you have studied all types, or only H you have studied?
Only H type.
Okay. And this change in the capacities of an barrette for C5 and phi and C, they are almost of the similar nature?
Yes, sir.
So in case of a C5 soil also, the increase in capacity
Yes,
is
sir.
significant?
Yes, sir. In all the three types of soil, similar pattern was observed.
Okay, what about the drilling? When you come to the drilling part of a H pile and a circular pile, what difference you feel?
Sir, the drilling process is same for the H-shaped barrette pile as that of the circular pile. And in fact, the time required to trench the barrette is less as compared to the circular pile. So H-shaped barrette is time saving as well as it is economical, as it provides you more vertical and lateral capacities.
And you have seen some practical examples where these H barrettes are used? Have you gone through some literature where they are using?
Yes, sir. Actually, one literature of Sohail Qureshi, they have experimentally done this of H-shaped barrette, and there also same results were observed.
Okay, so you can validate those results from your numerical studies?
Sir, I have not yet done validation, but I will do it.
Yeah, because that will be give some value to the work if you have the model comparison also.
Yes, sir, surely.
Okay, thanks a lot.
Thank you, sir.
Thank you everyone for being present here. So, Dr. Altaf, we are very thankful for you to sparing your time for us.
So all presentations over, Nipin?
Yes, sir, all presentations are over, and I think we can conclude the session now.
Okay, I think that was a good session. A lot of good papers, and I could heard different areas, people coming from the hybrid mat to the piles to some kind of bottom ash improvement in the soil. So good lot of research the students are doing, and they are presenting in the conference, and it will give them more confidence also to do more and more work and present it. And I think the presentations were all good, and there were few things which presentations can improve in terms of the slide numbers and other things, but overall it was a good session. Thank you.
Thank you, sir.